then solved solution. So
Hey Lana, welcome back. I'm Mercy Mboya. So in the previous lesson we talked about the indefinite article. I told you that we have two indefinite articles in English, and we also discussed on the uses of those articles, and I gave an assignment which I hope you've already completed and you've already seen where you've gone wrong. So in this lesson we'll be talking about the definite article. I'd already given the description, or I'd already described what a definite article is. So basically, we'll revise back through what a definite article is, and at the same time, I'll give the uses of the definite article, and then at the same time, give examples of sentences. So remember, I said that the definite article is only one. We said we only have one definite article in English, and we said the definite article is the article there. And then we said the name definite means that you use this article when you're talking about things that are specific. Unlike the indefinite article that we said are general, this article is specific. So you only use it when you're sure about whatever it is that you're talking about. So I'd already given you notes on the description, so we move straight to the uses. So we'll start with the uses. Uses of articles. Uses of article there. So basically, article there is the definite article there. So on to the first use. So I've already told you that this article is specific in nature. So the first use will be that used when talking about things known to the listener. So remember, this is the opposite. This is the opposite of what we said regarding the indefinite article. We said you use the indefinite article when you're talking about things that the listener does not know. But in this case, if you're talking about something that the listener knows, or something that is obvious to the listener, you make use of the article there. I'll give an example in a sentence. So for example, you want to ask somebody to answer a phone. You'll always tell them, answer the phone. And at the same time, as you ask them to answer the phone, you're already pointing to the phone. So the only thing that they can answer basically is a phone. So that is a bit direct. So that is an example of a, and this is a statement, answer the phone. So here we are using because the listener, the one that is listening to you, already knows what you are referring to. They already know that their phone is ringing. So you're telling them to answer the phone. Also, if we have another sentence like, this is sentence A, let's label that A. Another sentence like, I have a sister. No, let me use, I have a pen. The pen is lost. In such a case, I have a pen. So you realize when we are introducing the pen, when we are talking about a pen that the listener does not know about, we used a pen. But now that the listener already knows that this pen is mine, I have a pen, it is my pen. So that is why now we're introducing it using the article there, because it is something that is already known to the listener. So when you're introducing anything that you know your recipient already knows about, you don't say a pen is lost. You say the pen, because it is something that your listener already knows about. And then another instance where we make use of this article is when we are talking about, when you're talking about the different nationalities, when you're talking about the different nationalities, for example, and you're talking about the different nationality in groups. So for example, when you want to refer to the Japanese, when you say the Japanese are very innovative, you're not talking about one Japanese. You're talking about like the whole population. All Japanese are creative. When you talk about the Chinese people are great, or the Chinese people are this. When you say the Chinese, you're talking about all the people, all Chinese people. When you talk about Kenyans, the Kenyan, you're talking about a group of people, basically. So when you're talking a group of people, especially a group of people that belong to the same nation, you use such things. Also, so I've given example of the Japanese, the Ugandans. So basically, when you're talking about nationalities, where people come from, or the residents or the citizens of a specific country, when you're referring to them. And then now we can move on to use number 3. When talking about families, for example, when you say the Malays are rich, and you notice you have to, you not say the Malay, because you're talking about the entire family of Malay. So you have to add an S to show that you're not talking about one person from the family of Malay. You're talking about the whole family. When you talk about the Johns, maybe the Johns are visiting today. So when you talk about the Johns, you see, you're not referring to one person from the family of John. You're referring to all of them, all those people that that belong to that particular family. So that is use number 3. Then we go to use number 4. When talking about inventions. So when you talk about inventions, we basically mean when talking about those things that were invented by somebody. So for example, who invented the computer? So you notice you're saying the computer. For example, who invented the computer? So there you see you're talking about the computer. So you're making use of the. So who invented the computer? Who invented who invented the phone? Who invented technology, or who invented the internet? So when you talk about such things, about you want to ask questions about who invented what, the different things that we have, you are forced to make use of the article there. And then on to another use, number 5. So when talking about things that only one exists, that only one of them exists. So what this statement means, talking about things that only one of them exists, it means those things that they cannot be anything else that resembles them. For example, when you talk about when you talk about the earth, can we have any other earth? We cannot have any other earth. So the earth is one. When you talk about the sun, when you talk about the moon, when we talk about the stars, so these things that it is only one. We only have one sun. We cannot have two, or we do not have a different sun in another different time zone. So the sun is only one. So when you're talking about some of these things that only one of those exist, you make use of the article there. So I hope you can see this. And even when you construct a sentence using sun, you always talk about the sun is hot, the moon is bright today, or yeah, you always have to introduce these things, these rare bodies, using the article there. And then we move on now to another use, number 6. So you can also make use of this when talking about the common things. So when you talk about common things, I'm talking about those things that are common for everybody. For example, things like we always go to, we have the park, like we have Uhuru Park. So when somebody tells you I'm going to the park, automatically your mind already has an imagination of where they would be going. So like when you talk about something that is common, it is something that everybody understands. When I tell you I'm going to the theater, you already know I'm going to watch a movie. It's automatic. So that is why we are referring to these things as being common, because they are things almost everybody has used in their day-to-day lives. Also, we can have something else like the gym. When you say I'm going to the gym, this everybody knows what you go to do in a gym. I'm going to the hospital, also the hospital. So these are places that are common for almost everybody. We have yet another use, which is now number 7. So the 7th use, number 7, used before adjectives in the superlative form. So what this means is, okay, the superlative form basically is when you use adjectives to compare more than two things. So for example, you say she is the best in class. So when you say that she is the best in the team, she's the best in the team, for example, the best here, best, see, she's the best, like she's the very best, is the highest degree of comparison. You're not comparing her to anybody. No, she's like the best among all the people that are there. So best here is an adjective which is in the superlative degree. So before these types of adjectives, you have to make sure that you make use of the. So if you also say she is the most beautiful, she's the most beautiful. So here you see you've used the to introduce this adjective which is in the superlative, which is most beautiful. So every time that you're making use of this of adjectives in the superlative form, you have to make sure that you introduce when you say Mary is, maybe for example, is the weakest. So you see weakest, and we have the. So weakest is the highest degree of comparison, which is derived from the original word, which is weak. So when you say somebody is weakest, it means that they are the weakest, like that is the highest degree of weakness that they can be. If you talk about John is the most intelligent student. So when you talk about most intelligent, you see this is the highest degree of comparison. Like he is the best of the very best. Among the group that you have, John is actually the very best. So this is what we mean when you talk about the superlative forms. So every time that you're making use of the superlative forms, you can make use of this, and you can also write up as many sentences as examples, as many sentences as possible, so that it is easier for you to understand this use. And then we can now also move on to the next, which is now use number 8. So number 8, when talking about musical instruments, when talking about musical, this is a you musical instruments. So for example, when you want to say she played the piano well, so you noticed before piano we are using the. She played the piano, and the piano is a musical instrument. I'm sorry. So when you talk about things like the piano, the saxophone, the guitar, you say, how do you play the guitar? Or I have learned to play the guitar. So all, when you're talking about basically any musical instrument, you make sure that you use the article there. So I believe with those uses, you can be able to answer questions from this section. So because the uses are many, there are many. So what is required of you is a lot of practice. Make sure that you do a lot of practice. That is the only thing that will help you to be able to understand this. So some of these concepts, you cannot learn them by just cramming them, because cramming is very different from actually applying a concept. So the only way that you can learn application of a concept is through practice, a lot of practice, practice in speech, practice in answering questions, practice in writing, so that these concepts are in you. So cramming is a no, and it will not work in this section, because the examiner will not ask you to give instances when you're supposed to use the article there. Instead, they will give you an exercise. So as you answer the exercise, you will be required now to revisit this. So make sure that you understand everything that we've talked about here. So I'm just going to do a brief recap of what we've talked about. So basically, we were talking about the definite article. I said the definite article is only one. I had mentioned that in the previous lesson, that the only definite article that we have is the article there. And then we also talked, I also said it's referred to as a definite article because it is definite in nature. Like basically it's not a general article, it is specific. It is used when we want to talk about specific things. So we've gone through the uses of this article. We've talked about the fact that it is used before adjectives in the superlative form. I'm not following any particular order, so I'll just revisit the ones that we've covered. So we've talked about the superlative form. I've explained what the superlative form is. We've also talked about this when you're talking about different nationalities. For example, when you want to talk about the Kenyans, or you want to talk about the Swedish or the Swiss people, you always make use of the. And then also when talking about family names, or basically when you want to make when introducing people that belong to one family, or basically talking about something common about a family. So you want to say the Johns, the Georges, you always have to add an S, and then you also see that you have to add the article there before the actual name of the family. We've also talked about when talking about things that only one of them exists. Basically, when talking about things that are unique. And we've talked about the earth, the sun, the stars, those things that are unique. Even the 9 planets, the planets, they're unique. We do not have any other planets. It's only those ones. And then when talking about the common things, so I've said common things are basically those things that are common for everybody. Like when somebody talks about going to the gym, when somebody talks about going to the toilet, you'll not have to ask them which toilet. When they say they're going to the toilet, it's something that is common. You already know what they are talking about. So for that reason, you are required to use there. And then we've also talked about the fact that you use there when you're talking about things that are already known to the listener. So if you're talking about something that you'd already mentioned earlier to the listener, you'll also make use of the article there. So I think in summary, that is what we've done in this lesson. So I have an assignment which I'm going to read out for you. So in that assignment, you will be required to fill to use the articles, that is both the definite and the indefinite articles, appropriately. So these are the instructions. Fill in the gaps with a, an, the, or no article. So in the instances where you feel you do not require an article, you will put a tick, a small tick. So the first sentence, she is a dash vegetarian, so she doesn't eat dash chicken or dash fish. So I'll repeat again. She is dash vegetarian, full stop, so she doesn't eat dash chicken or dash fish. And then on to sentence number 2. So can I use your phone to send dash email? Can I use your phone to send dash email? And then sure, but you do it quickly. So can I use your phone to send an email? Question. And then sure, but do it quickly, full stop. Dash, battery is low, full stop. So those are basically three sentences, somebody asking a question and another person responding. Sentence number 3. I heard there was a dash burglary in our neighborhood last night. I heard there was dash burglary in our neighborhood last night. The police think that dash local criminal gang may have been involved in the crime. The police think that dash local may have been involved in the dash crime. And then sentence number 4. Mr. Dominic is dash experienced language teacher. Mr. Dominic is dash experienced language teacher, full stop. He has taught dash Spanish to hundreds of dash undergraduate students, but he also enjoys teaching dash children. But he also enjoys teaching dash children. And then number 5. Number 5. Do you have dash ink eraser? Do you have dash ink eraser? And then lastly, dash money is important, but it can't buy dash happiness. Other things like dash family, dash lasting friendships, and dash satisfying job are far more important dash life. I'll repeat the last one. Dash money is important, but it can't buy dash happiness, full stop. Other things like dash family, dash lasting friendships, and dash satisfying job are far more important in dash life. So I hope the assignment is clear for everybody. So I want us to talk about something I'm just mentioning something that I didn't mention earlier, that we're allowed to use there are instances where you cannot use either of these articles. There are some instances where you're not supposed to use an article, and there are only 2, and I want to point them out. The first instance is when you're using proper nouns. So for example, when you remember we said proper nouns are those specific names of people or specific names of places. So for example, you cannot say the John or the James. If you're talking about James alone, you have to say James. But if you want to refer to James, like the family of James, all of the people that are associated with James, you can talk about the James family or something. But if you're talking about James alone in singular form, it is only James. So with most proper nouns, you're not required to use to use the articles. There are some exceptions, however, because you see, oceans, the names of oceans are also proper nouns. So for example, Indian Ocean. But most of the times we find ourselves saying the Indian Ocean, the Red Sea, the Kalahari Desert. So for those or the United Arabs, the United States of America, we find ourselves putting there before some proper nouns because that is how they've been written. So there are some exceptions to this rule. But mostly when it comes to the names of people, you shouldn't actually use an article. Also, when you're talking about languages, so you do not introduce the article when you're talking about languages. So that will be all. You can also continue reading from your books and doing research, because I'm sure some of you were able to do that, and find out whether we still have other instances where you cannot use an article. So until next time, that is the end of the lesson. I hope you enjoyed. Bye.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi, and today we continue with our topic of discussion. The topic is acids, bases, and indicators, topic in Form 1 chemistry. So at this point, we are going to discuss commercial indicators. And this is in addition to what we discussed the last time, whereby we discussed the extraction of indicators from plant extracts. And we saw the disadvantages of those indicators that are obtained from plant extracts, and that is now why there is need for commercial indicators. So commercial indicators give consistent results. They can be stored for a long time for future use, and so on and so forth. And we'll have various examples. We have, for example, an indicator that is called litmus. Litmus can either be in form of a solution called litmus solution. It can also be in form of a paper called litmus paper. We have other commercial indicators such as methyl orange. There is phenolphthalein. There is screened methyl orange. There are many. There are bromothymol blue. So there are several. But of course, we'll only mention the common ones, the ones that are commonly used in our laboratories. So we can say that common commercial indicators include, we have litmus, we have methyl orange, there is also screened methyl orange, there is phenolphthalein, there is a bromothymol blue. So all those, they are commercial indicators, but we'll mainly mention the litmus and the methyl orange and phenolphthalein, because those are the common ones that we actually use. So we can first of all say that these indicators give consistent results. So they cannot give you results today and then tomorrow they give you results that are different. So they'll have to be consistent. That's why they are more recommended as compared to the simple ones that are obtained from plants. So these ones are basically the ones that we use. So they give consistent results and can be stored for future use. So at this point, we'll have a table showing the effects of commercial indicators on different solutions. Effects of commercial indicators on different solutions. So we'll put these as a table. So we'll have a solution being tested in the first column. Then here we can use litmus paper is one of the indicators, or we can still use the litmus solution. They just give the same results. Then we have methyl orange indicator, and then we have phenolphthalein indicator. So for example, we can take lemon juice. If you test it with litmus paper, the color turns red. So you can mention somewhere here that this is the color obtained using either of those indicators, using litmus paper. So when using a litmus paper, the color obtained is red with lemon juice. When you use methyl orange, the color here is pink. When you use phenolphthalein, it's colorless. So you can see that different indicators give us different colors with the same solution. On the other hand, if we use something like soap solution, with the litmus, the color will be blue. With methyl orange, the color will be yellow. And with phenolphthalein, the color will be pink. So you can see all of them are giving us different colors. We take an example of hydrochloric acid. In litmus, it will be red. In methyl orange will be pink. And in phenolphthalein will be colorless. So we can observe something here, that hydrochloric acid is behaving the same way as lemon juice in all the indicators. And that is an indication that lemon juice and hydrochloric acid are acidic. They are acidic. But soap solution is not acidic. That's why it's giving us different colors. If you take something like caustic soda solution, so this one will behave like the soap solution. Blue with litmus, yellow with methyl orange, and pink with phenolphthalein. So 2 and 3, they have similar properties. That means caustic soda solution and soap solution, they are bases. They are bases. That's why they are giving similar colors with the various indicators. If we take an example of distilled water, the litmus is purple, the methyl orange is orange. That means the color remains orange. Litmus, the color remains purple. Phenolphthalein, the color is colorless, it remains. So for distilled water, this is neutral. It's neither acidic nor basic. It's not behaving like the others. That shows that it has its own properties that are different. So the list can be long. We can have as many chemicals as we want. But something that is worth mentioning, we can say that from the above table, we can say A, lemon juice, hydrochloric acid, we can still use sulfuric acid, all give similar, they give similar colors with different indicators. They give similar colors with different indicators. They are all acidic. All of them are acidic. That's why they are giving the same colors. Lemon juice, hydrochloric acid, even if we were to use sulfuric acid, it will give us all those colors. So that's an indication that all acidic substances will behave like that. On the other hand, we can say that soap solution, caustic soda solution, we can have potassium hydroxide, sodium hydroxide, and others not on the list. They also give similar colors with different indicators. With different indicators above. They are all basic. So they are all bases. So they are bases because they have their own color that they are giving us that is different from those that are acidic. Remember we said that the work of the indicators is to tell us, is this an acid or is this a base? If it is an acid, it gives you a certain color. If it is a base, it gives you a different color. Then we have distilled water that is giving us a completely different color from the others. So here distilled water, we are saying that it is neutral because the litmus remains purple. It doesn't turn red or blue. The methyl orange remains orange. Phenolphthalein remains colorless. So that is an indication that they are neutral. So you can say that distilled water and common salt solution even sugar solution can also use it there. They do not change the color of indicators. They do not change the color of indicators above, i.e. they are neutral. They are neutral. And neutral means neither acidic, they are neither acidic nor basic. So they are not acids and they are not bases. Distilled water, common salt, sugar solution, those ones have no effect on the indicators. But you can see that lemon juice, hydrochloric acid, sulfuric acid, those ones are acidic. They are giving you similar colors. If it is using litmus, all of them are red. If it is using methyl orange, all of them are pink. If it is using phenolphthalein, they are colorless. So if the behavior is the same, then it means that they have similar properties or they have the same properties. So we can summarize that again and say that we can have the indicator, then we can have color in acid, base, and neutral solution. So for example, we can start with the litmus. In acid, it is red. In base, it is blue. In neutral, it's purple. So we are summarizing this from here. If it is methyl orange, in acid, it is pink. In base, it is yellow, as we can see there. And then in neutral, it's orange. And then finally, phenolphthalein. As another indicator, in acid, it is colorless. In base, it is pink. In neutral, it's also colorless. So this is the conclusion that we've got from the first table. We have an indicator, and then we have the various colors that it gives us. If, for example, the solution is acidic, if it is basic, and if it is neutral. So color in acid, litmus is red. In base, it is blue. In neutral, it's purple. Methyl orange, in an acid, it is pink. In a base, it is yellow. In a neutral solution, orange. Phenolphthalein, if you put it into an acid, it is colorless. In a base, pink. In a neutral solution, colorless. So that tells us that indicators give us different colors in an acid and different colors in a base. So you can have an assignment. So the first question, complete the table below, the indicator, the color it gives in an acid, the color it gives in a base, and in a neutral solution. So starting with phenolphthalein, methyl orange, litmus paper in each. And then question number 2, why is it advisable to use commercial indicators in the laboratory? Why is it advisable to use commercial indicators in the laboratory? So we'll stop there. Until next time, goodbye.
Hello, Lana. Welcome once again to Manifested Online Classes. My name is James Kenyani. We are going to continue with our topic on SADs, and in today's lesson, we shall look at multiplication and division of SADs. So the lesson is multiplication and division of surds. The main objective of this lesson is to enable the learner to do operations on surds involving multiplication and division. So it is to enable the learner to work out operations on surds involving division and multiplication. So we do that by looking at various examples. So you can be told evaluate the following. So those are the operations we have to evaluate. We have the first one, learner, square root of 2 times square root of 2. B, square root of 2 times square root of 3. C, 2 square root of 6 times 7 square root of 10. D, square root of 10 divided by square root of 5. And E, 2 square root of 15 divided by square root of 3. So what you do in such operations, so you look at the solutions. We have in A, when we have square root of 2 times square root of 2, you can combine all of them in one inside the square root sign and have 2 times 2. You can combine all of them inside the square root sign, learner, and you have square root of 2 times 2. That gives us what? Square root of 4. But 4 has a perfect square. 4 has a perfect root. So the answer is 2. What has happened? You put them inside one root. You put them inside one root. We come to B. Square root of 2 times square root of 3, learner. Just as in the same first operation, put all of them under one root sign. So it will be the same as root square root of 2 times 3 and learner. That gives us square root of 6. We come to C, which looks a bit different, learner. We have 2 square root of 6 times 2 square root of 6 times 7 square root of 10. So what will happen in such? You'll pull together the numbers that are not in the root sign. You'll put together all those numbers. So what you'll have is 2 times 2 times 7 then the root sign 6 times 10. 6 times 10. So you'll come and have 2 times 14. 2 times 7 you'll have 14. Then here 6 times 10 will be square root of 60. But once you get square root of 60, will you look, are there any multiples of 60 that have perfect roots? You can try to juggle about. We have 2 times 30. We have 4 times 15. 4 times 15. So it doesn't end here. You have to look for this number you find inside the root. Like for example, we have 60. 60. Then you say, but 60 is equal to 4 times 15. 4 times 15, and 4 has a perfect root. A perfect root. So what you've got here will be the same as 14 into square root of 4 times 15. So you be very careful there. But 4 has a perfect root. 4 has a perfect root. So it will come out. It will then become 14 times 2. It has come out square root of 15. Because the 4 has a perfect root. So it comes out and you remain inside with the 15. So 14 times 2, you'll get 28. The answer will be 28 root 15. That is the simplified evaluation of that. We come to D. We come to D. D. So you note the final answer you'll get. You look for the multiples. If any of the multiples has a perfect root, you simplify it further. D, square root of 10 divided by square root of 5. This is written under one root as 10 over 5. 10 over 5. But what is 10 over 5? What is 10 over 5? It will give us square root of 2. The answer is square root of 2. We move to E. We move to E. So Lana, we move to E. You check the operations. 2 square root of 15. 2 square root of 15 divided by square root of 3. So what happened in D will likely happen in E. It is the same as having 2 times, then you put a big square root sign, 15 divided by 3. So the numbers that had the third form, the root form, are collected in the bracket. Over here, meaning it is a division. It is a division. That works too. 15 divided by 3 is 5. So it is 2 root 5. The answer will be 2 root 5. 2 root 5. So in general, Lana, square root of m times square root of n is equals to, into brackets, m n. Mn. Think you understand that? When we had the multiplication, like here, you see how it worked out. It is the same as having all of them in the same bracket. All of them in the same Mn. Mn in the same bracket. It's the same as having one root sign where under it we have n multiplied by n. And when you have division, and 2, this is 1, in 2, m square root of m divided by square root of n is the same as having one root sign with m over n. That is what we get when we have those operations on multiplication and division. So just a small recap, square root of 2, square root of 2, we pulled it in the same bracket. Square root of 2 times square root of 3 pulled in the same bracket. That's why we got square root of 6. When we came here and it came to having square root of 60, 60, one of the multiples 4 had a perfect root. That's why we simplified it further to 28 root 15. And the same continued here. When we had division, we put it into the same bracket and you divide. That's why we got square root of 2. The same applied here. 15 divided by 3, but under the same square root sign. So for the assignment, so that is the assignment, learner. We have A, square root of 5 times square root of 2, B, 2 square root of 3 times 5 square root of 7, C, square root of 11 times square root of 9, D, 3 square root of 3 times 5 square root of 2, E, 6 square root of 2 times a half square root of 3, F, 8 square root of x times 2 square root of y, G, 2 square root of 3 times a fifth square root of 5 plus 8 square root of 23, H, square root of 162 divided by square root of 72, I, square root of 125 divided by square root of 5, J, square root of 360 divided by square root of 160. Working out through those questions in the assignment will give you a perfect practice of operations on multiplication and division of surds. Thank you very much for the audience, and let's meet in the next lesson to proceed on the topic. Bye-bye.
Hello students, welcome to today's session of the Manifested e-learning platform. Today I'm going to talk about idiomatic expressions. Now, idiomatic expressions is a very key aspect in meriting, ensuring that you get a merit tick when you're writing a composition. In paper 3, we normally look at what makes that student score an A in that composition. We focus centrally on maybe the use of vocabulary, the use of variety of sentences, as I mentioned earlier. We also look at use of phrasal verbs, maybe description, and one of the other aspects that can ensure that a student gets a merit tick is by using idiomatic expressions. Not necessarily on every line, on every sentence, but at least you can throw one here and there so that you can ensure that your composition is creative and sounds mature, shows that you have complete mastery of language, you have competent use of language, you have linguistic ability is a bit high. Now, it's very important that much as we are talking about idiomatic expression, don't just listen to this lesson only. Make sure that you also go research, okay? Do your own revision, find other ways of getting more idiomatic expression that can help flower your language. Even when you're writing the composition, ensure that you include one here and there in one paragraph, in the other paragraph, in the other paragraph, okay? So that you can ensure that your composition sounds grammatical and also creative. Another thing is that it also helps in speech. When you're talking to people, you know, when you throw an idiom here and there, it makes sense. It makes the other person know that you can use English as a normal way of expressing yourself. So it's an important aspect, not just in speech, but also in writing and also in use in everyday life. Okay, even when you're delivering your speech to some people, you know, when you throw in an idiom, it can drive the point home. All right, so it's not something that you can just learn and now put the books away. No, it's something that will help you when you're using it in everyday life. So idiomatic expressions So these are expressions whose meaning is contrary to the individual interpretation of the words found in the phrase. For example, if we say bury the hatchet, okay, so we've said that it's a type of an idiomatic expression, but it doesn't mean that now you bury a hatchet, okay? It just means you stop, maybe you stop fighting, okay? Majorly stop an argument, stop quarreling, all right? So the meaning of the idiomatic expression does not, it is not direct, it is contrary to the direct interpretation of the individual words, all right? But it's a phrase whose meaning is different. It has a deeper meaning, all right? It's a phrase with specific meaning. So it is a phrase with a specific meaning. It is a phrase with a specific meaning. Let me give you some of the examples, and then we will do one exercise, and then we will see how we can use them even in sentences. So one example is, so one of our examples, these are several examples of what? Idiomatic expressions. Examples. This is M of okay. So one of our examples is close-fisted to mean mean, get into hot soup to mean get into trouble, no love lost mean to not like each other, have a ball to mean have a good time, steal the show to mean attract all the attention, hold your tongue to mean keep quiet, keep a straight face to mean not to smile, and then between a rock and a hard place to mean in a difficult situation. Again, when you're using them in compositions, make sure you don't use the ones that are overly used. All right, avoid the cliches. At least come up with new ones. You know, as you interact with more text, as you interact with more books, you will encounter different and new idiomatic expressions to help flower your language. So let's have at least a few examples in sentences. So a few examples in sentences. The teacher told the student to hold his tongue. During the graduation ceremony, we had a ball, meaning we had a lot of fun, as we always say. We had a good time. And then the teacher told the student to hold his tongue. The teacher told the student to keep quiet. And then there was no love lost between the two brothers, even after many years of staying away from each other, meaning the two brothers did not like each other. Okay, no love lost means to not like each other. So I want to, other examples could be I was caught between a rock and a hard place after I sneaked out of school, or maybe something like we got into hot soup when we fought with each other. All right, and then maybe my father is a close-fisted person to mean he is very mean. My father is a close-fisted person to mean he's mean, among other examples. All right, so I'm going to give you two assignments. One, you will need to maybe answer, and then the other one, you'll need to use them in sentences, like we've done in the ones that we have on the whiteboard. Okay, so in the exercise, choose an appropriate idiom from the box and use it in the correct form. You're replacing the underlined words, all right? The two, for question one, Masika's lousy jokes irritated Njogu. So you choose one to replace the word irritated, okay? And then you use it in the correct form. For example, in example one, Masika's lousy jokes irritated Njogu. The answer would be, rub somebody up the wrong way. So Masika's lousy jokes rubbed Njogu up the wrong way. So you're supposed to use it in the correct form. So the two never quite agreed on how to invest in their money. Okay. Njogu doubtfully accepted Olwach's suggestion that they buy the plot. Number 4, the new factory was the latest unnecessary and expensive venture to be put in the area. So replace unnecessary and expensive venture. Okay. Number 5, unexpectedly, Mzee Ochiel decided to plan his own funeral. And number 6, the clown's performance caught great excitement and applause. So from the 5, okay, make sure you choose what? The best answer. You see 1, 2, 3, 4, 5, 6. So from the 5 that I've given you, I've already given you the answer to question 1. Choose the best one and make sure you write it in its correct form so that the sentence remains grammatical. All right? You're not just fitting and replacing. You're also ensuring that as you replace, you're using it in its best form. All right? Now, one last assignment and then we'll be done with idiomatic expressions. So in exercise 2, use the idiomatic expressions below to construct sentences of your own. So the question, sentence 1 is to speak volume, so you use that, all right? Number 2, to go down memory lane. Number 3, keep or lose track of. You can use either to keep track of or you can use either to lose track of. Number 4, to play upon somebody's sympathy. Number 5, a chapter of accidents. Number 6, take the bull by the horns. Number 7, bury the head in the sand. So use either, use all of them, not either, but use all of them to construct sentences of your own. All right. Having said that, we have come to the end of the lesson. I hope you have understood what idiomatic expressions are. They are expressions with specific meanings, such that you don't get the meaning of the idiomatic expression from the individual interpretation of the words in the phrase. All right. And another thing is that we have given various examples, and you can use them to flower your language. You can also use them in speech. You can even use them in when you're delivering a speech to some people. So it's not something that can only help you in grammar, but also in composition writing, but also in developing your grammatical skills. All right. So have a wonderful time, and we'll meet next time.
Welcome to our physics lesson today. I'm your teacher Purity Anzelimo, and in our lesson today we continue with the topic X-rays. So the topic is X-rays. And in our lesson today, we'll actually be concluding this topic, the X-rays. So before I mention what we are going to cover during this lesson, I would like us to do a recap on what we covered during our previous lesson, where we were looking at the intensity or the quantity of X-rays and also the strength of the X-rays. We said that with the strength, of the X-rays is determined by the accelerating potential difference between the cathode and the anode. So you need to make note of that because it will depend on the speed of the electrons which have been produced. So the strength of X-rays is determined by the accelerating voltage between the cathode and the anode. Make note of that because we think that the more the accelerating voltage between the cathode and the anode, the higher the speed of the electrons which are emitted, and therefore the higher the strength or the more the strength of the X-rays that will be produced. Then number 2, we talked about the intensity or the quantity of X-rays. And this one is controlled, or the intensity is controlled by the heating current. So we were able to see that, and we were able to explain that when the heating current is more, then there will be more heating at the cathode, and therefore more electrons will be emitted. And when more electrons are emitted, it means that more X-rays will be produced. So the higher the heating current, the more the quantity of the X-rays produced. So during our lesson today, we want to look at now the uses of X-rays. This may not be very new to you because in the topic electromagnetic spectrum, where we looked at X-rays as part of the electromagnetic waves or as part of the electromagnetic spectrum. So we are going to list those down those uses of the X-rays. We are going to divide them. For example, what are the uses of X-rays in medicine? What are the uses of the X-rays in agriculture? What are the uses of X-rays in science? What are the uses of X-rays in security? So we look at those uses because in an exam you can be told, for example, give one use of X-rays in medicine. So they can be specific to that area. So we want to look at the uses of X-rays, and we'll start with one of the categories is in medicine. In medicine, and I'm sure maybe you have ever visited a hospital, or maybe you have ever taken a friend who has undergone an X-ray. So in hospitals or in medicine, we want to see how X-rays can be of use. Now in hospitals, or what we are calling in medicine, it can be used in what we call the radiography. And we want to explain first about radiography because we can use it in radiography and also in radiotherapy. So in radiography, this is where, because X-rays, we say they have high penetrating power, even because of their position in their electromagnetic spectrum. They have high frequency and therefore they have high penetrating power. So due to their high penetrating power, they can be able to inspect the fractured bones or dislocated joints. That is in what we call the, in taking the radiographs, that is in X-rays. In taking radiographs, that photography that is obtained after one undergoes an X-ray is what we call a radiograph, and thus can be used to study the internal structures, that is the fractured bones and also the dislocated joints. So that is in radiography. So we can say that in radiography, due to the penetrating property of X-rays, we can say that fractured bones and dislocated joints can be seen. Fractured bones and also dislocated. We say that they can be seen from X-ray photograph. They can be seen from X-ray photograph, which we are calling called the radiograph. Called the radiograph. So in a photograph, an X-ray photograph called the radiograph. So when you undergo, for example, maybe if an accident occurs and maybe there is a swelling, maybe in one of your bones, let's say the leg bone, let's say at the ankle. So before the doctor treats you, he or she may tell you to undergo an X-ray. And that X-ray, now you produce, when you go for the X-ray, you will take the radiograph to the doctor, and the doctor will be able now to examine and see what the issue with your ankle. So due to the penetrating property of the X-rays, fractured bones and the dislocated joints can be seen from X-ray photograph, which we are calling the radiograph. So that is one use in medicine. Use number 2, still in medicine, is what we are calling the radiotherapy. The radiotherapy, there is a H here, radiotherapy. Now in radiotherapy, here this is where now we talk of the treatment of diseases like the skin diseases, cancer, and X-rays are used to destroy the infected tissues. So X-rays can also be used in the treatment of cancers, that is the cancerous cells, and also the other skin diseases by exposing the X-rays to the infected areas. So that is in radiotherapy. So we can see the following in radiotherapy, that we can see that hand X-rays, especially now the hand X-rays, since we see that they have a higher penetrating power, they are the ones that are used in the treatment of cancer. So hand X-rays, they are used in treatment of cancer, tumors, and other skin diseases. So the hand X-rays are used in treatment of cancer. We also have the tumors and other skin diseases. So what they do, they destroy the X-rays, destroy the tissues, or they destroy the tissues at the infected areas. They destroy cells at the infected areas. So when you hear someone has undergone a radiotherapy, of course there are some dangers on long exposure to X-rays, but in addition to that, we still have the advantages of those rays, because they can be used in the treatment of these diseases, cancer, the tumors, and other skin diseases. So because of their high penetrating power, again, that's why they can be able to destroy, and because of their energy, they have a lot of energy, and therefore they can be used to destroy the cells in the affected or in the infected areas. So that is in radiotherapy. Is there H? No, it shouldn't be therapy with just Y. So in radiotherapy, that's how the X-rays are used. Then we can move on to another area where X-rays are used. Number 2, we can talk of in industry. Now in industry, X-rays are also very key. One, they can be used to detect flaws or any crack in metals. So before those metals maybe are packaged for use, the X-rays, because of their high penetrating power, they can be used to detect the cracks or the flaws in metals. Again, in industry, the X-rays can also be used in sterilizing the medical equipment before packaging. So we can say, number 1, they can be used to detect flaws on what we are calling the cracks in metal casing. Then again, they can be used to sterilize medical equipment before packaging. So those are the uses of X-rays in industry. They are used to sterilize the medical equipment before packaging. They can also be used to detect cracks in metal casing. Now we move on to another area where X-rays are used. That is number 3. We can talk of in science. In science, what we refer to as crystallography. In crystallography. Now from this one we have crystal. So in science, X-rays can be used in the study of the structure of a crystal. In chemistry, you learn about crystals. So as a use of X-rays, they can be used to study the structure of a crystal. That is in science. That is how the layers are. That is in the atoms in a crystal. So it can be used to study those internal structures of a crystal. So that is in science, to study the structure of a crystal, or what we call the crystal substances. Then again, we can also use the X-rays. Number 4 can be used also in security. And here in security, majorly in the airports, where inspection has to be taken for any luggage that is to be transported. So it is used to inspect luggage in airports, so that in case of any hidden material that may be dangerous, so that it can be detected by the X-rays. So when one is also taking a flight, the luggage that you carry has to be inspected. And what takes place is that rays, that is the X-rays, are passed on your luggage for any hidden material. For example, any weapon that may be hidden in the luggage. So we can say that in security, it is used to in airports. We give an example in airports. To inspect, sorry, not to detect, but to inspect. So that is in security. It is able to inspect the luggage because of, again, of its high energy. It's able to penetrate the luggage and inspect in case there is any hidden weapon. So that is in security. We've also mentioned the industry area We've also talked about science and also in medicine. And in medicine, we can also add another use in medicine. In medicine, X-rays can also be used to detect. For example, if there is a foreign object that has been swallowed, for example, if you swallow a coin, it can be detected by the help of the X-rays. So we can also add that as a use of X-rays in medicine. In medicine, we can add and say that in this the continuation, we can say that it can be used, X-rays are used to swallow fallen objects, fallen objects, that is in the body, a swallowed coin, or even a pin. So used to detect foreign objects in bodies, a swallowed coin. So those are the uses of X-rays. So we have seen that we can divide them into 4 in medicine. So you don't need to write a lot. For example, in medicine, you just talk of in radiography, where it is used to study the fractured bones and dislocated joints. Then in radiotherapy, we are saying it can be used in the treatment of cancer, treatment of tumors, and other skin diseases. And then we are also saying in medicine can be used to detect foreign objects in bodies, a swallowed coin or a pin. Now in industry, you just talk of used to detect cracks in metals, used to sterilize medical equipment before packaging. In science, used in crystallography, where we study the structure of crystal substances. Then in security, to inspect luggage for any hidden weapon. So those are the uses of X-rays. And now we want to move ahead and look at the dangers of X-rays. Despite the fact that X-rays are very useful, actually like in medicine, this is what we rely on, the X-rays. Despite the fact that they are very key in our day-to-day lives, they also have some dangers when they are overused. So long exposure to X-rays can be detrimental to health. For example, we can say that one of the dangers of long exposure to X-rays is that it can affect the skin. It can even lead to cancerous cells due to its long exposure. So care must be taken even when one is undergoing the X-rays. So we can say that the penetrating property of the X-rays can cause genetic changes and even diseases like cancer. That is on long exposure. So number 1, due to and that's why you are always asked when maybe, for example, you go to a hospital and you want to undertake an X-ray, you are asked how many X-rays have you gone through, maybe in that year, because a lot of exposure to the X-rays can be very detrimental. And again, that's why in the rooms where X-ray machines are kept, there are not many people in those rooms. Actually, when you take a person to undergo an X-ray, you'll be told to wait for that person outside that room because of those X-rays. Because in case there are stray X-rays, if they land on your body or on your skin, they can lead to health issues. So due to the penetrating power of X-rays, it can cause genetic changes and other diseases like cancer on long exposure or due to long exposure. Then we can also say another danger, we see that they have high ionizing power. X-rays have high ionizing power, or they are able to ionize gases. That is what we said in one of the properties of X-rays. we say that X-rays ionize gases, making them conductors. And therefore, due to their ionizing property, X-rays can damage the body cells. So due to their ionizing property, X-rays can destroy body cells. That is again on long exposure to the X-rays. And due to their ionizing property, where we say that they are able to ionize gases, making them conductors, then they will lead to destruction of the body cells. And therefore, care must be taken, especially when in the rooms where X-ray machines are kept. So we also look at the precautions when using the X-ray machines. Precautions, what you need to take care of when you are operating an X-ray machine. Precautions. So we have two major precautions that need to be taken when using the X-ray machines. Now these X-ray machines are the ones which are producing the X-rays. So number one precaution is that the room where the machine is kept should be a room that is built of concrete or a hand material which is able to absorb any stray X-ray. So in case, because we have seen that for even the hand X-rays, they are absorbed by the bones, so they may not be able to penetrate the concrete walls, and therefore an X-ray machine should be kept in a room which is made of hand materials like concrete, so that the X-rays cannot penetrate. And if you look at most of the hospitals, if not all, where the X-ray machines are kept, you'll find that that room is made of concrete, or it's made of stones, because they are hand and therefore the X-rays cannot penetrate. So that is one of the precautions that need to be taken. Then we also say that those machines, when we are looking at the X-ray tube, we also say that the X-ray tube should be covered or should be coated with a metal of high density that is lead, to ensure that any X-ray that is undesirable, produced at an undesirable angle, is absorbed by that material. And a good example, we said we use lead metal, and the reason as to why we use lead is because it is a metal of high density. So we can say number one, X-ray machines the X-ray machines have lead shield, and this is to protect the operator from stray X-rays. So that's one of the precautions, that X-ray machines have a lead shield to protect the operator from the stray X-rays. And you can be asked why lead is preferred. We have said because it is a metal of high density. Then number two, we can say that the rooms of operation have concrete walls. They have concrete walls to absorb any leaking radiations. And these radiations are the X-rays. So we are saying that the rooms of operation have concrete walls to absorb any leaking radiation or any leaking X-rays. So these are the precautions that need to be considered when using the X-ray machines. X-ray machines have lead shield to protect the operator from the stray X-rays. So the lead is able to absorb the X-rays. Then the rooms of operation have concrete walls to absorb any leaking radiations. So those are the precautions that need to be taken when operating those machines. So those are the uses of X-rays, the dangers of X-rays, and also the precautions on using the X-ray machines. Very examinable. You can just be asked a question from any part here. You can be told to give one danger on exposure to X-rays. You can be told, you can be asked, for example, to give a precaution on using the X-ray machines. You can be asked why the lint method is preferred for shielding purposes in X-ray machines, and you should be in a position to explain all that. So I'd like to give you an exercise on what we've looked at on the uses and the dangers of X-rays. So I want to give you an exercise. 2 questions on this. Number 1, state 1. So state 1, agricultural use of X-rays. Number 2, give 2 dangers of long exposure to X-rays. And that brings us to the end of this topic, that is the X-rays. So you can revisit the other lessons for you to understand better. So during our next lesson, we'll now do a summary of what we have been covering in X-rays, and we'll also do a question from the past papers, that is KCSE past papers, and you'll be able to get it better. So let's meet during our next lesson so that we can summarize the topic. Thank you.
Hello Lana, my name is Dickens, and we are talking about salts. And in today's lesson, we want to look at methods of preparing salts. I want us to start by knowing what are these methods of preparing salts. There are about 5 methods of preparing salts. So let us start by mentioning them. Method number 1, you can prepare a salt by the reaction between an acid and a metal. If you react an acid and a metal, you'll get a salt and hydrogen gas. Method number 2 of preparing salts is a reaction between an acid and metal oxide. That will still give you a salt. You'll get a salt and water. Our third method of preparing salts is reaction between an acid and metal hydroxide. If you react an acid and a metal hydroxide, you'll get a salt and water. Method number 4 is reaction between an acid and a carbonate, metal carbonate, or you can still use hydrogen carbonate. Hydrogen carbonate. Then lastly, method number 5 of preparing salts, we call it direct synthesis. Direct synthesis. So these are the 5 main methods of preparing salts. So we are going to start with method number 1, and that is reaction between an acid and a metal. So method number 1, reaction between an acid and a metal. Reaction between an acid and a metal. Reaction between an acid and a metal. So that's our first method of preparing salts. We shall do that by focusing on one specific example, and then we shall give other examples using chemical equations. So we focus on preparation of zinc sulfate. Preparation of zinc sulfate. This will give us a foundation, and then from there we can be able to look at other examples of the same using chemical equations. So how do you prepare zinc sulfate? This is our procedure. Number one is you measure about 20 centimeters cubed of dilute sulfuric acid and put in a beaker. You measure, of course, using a measuring cylinder. Then secondly, add zinc powder to the acid as you stir. So the reason for stirring is simply to allow enough time of reaction between the acid and the zinc metal. Thirdly, continue adding zinc powder until it is in excess. So we are using excess zinc simply to make sure that all the acid has reacted. That's why we are saying we add more and more zinc until all the acid has been used up. Remember, the reaction that is taking place here is the reaction between zinc powder and dilute sulfuric acid. Fourth, you filter the resulting mixture and transfer the filtrate into an evaporating dish. So we are carrying out filtration. Remember, in the procedure, the third point we have said, we are using excess zinc. So some of the zinc will remain unreacted. So how do you remove the unreacted zinc? By simply carrying out filtration. So we filter to remove unreacted zinc or to remove excess zinc. After which you will get a filtrate, and that filtrate, remember, the reaction is between zinc and sulfuric acid. So the reaction takes place, we shall get zinc sulfate and some hydrogen gas. So the solution that we'll get will be the filtrate, and the filtrate is actually zinc sulfate. So that filtrate is the one that will transfer into an evaporating dish. And once we mention evaporating dish, it means we are supposed to heat. So our fifth point is evaporate the filtrate to saturation. So saturation means the point at which this solution will be able is now ready to form crystals. That's the point we are calling up to saturation. So we have said, how do you tell that the salt is ready to form crystals? We said you simply take a clean glass rod and then you dip into that evaporating dish containing the filtrate. After that, you remove it and then hold it in the air, then allow it to cool. You observe the glass rod. Once you see crystals on the glass rod, it means the solution is ready to form crystals. After which you now remove it from the source of heat and then you allow it to cool. So that is our sixth point, that allow the saturated solution to cool. We have said this solution is said to be saturated simply because it's now ready to form crystals. So this is how our setup will look like. Initially, we are going to have our first beaker. The beaker here contains a mixture of sulfuric acid and zinc. It contains a mixture of sulfuric acid and zinc. So here we shall put a mixture of, this is our beaker. So this beaker, inside it we have zinc powder, and then we have our sulfuric acid. So that's what we mix in the beaker. And then after mixing, remember we have said we are using excess zinc. We are saying that some of the zinc will remain unreacted, and we have said how to remove the unreacted zinc by simply carrying out filtration. So during filtration, we need a filter paper. We also need a filter funnel. So this is how you should have your apparatus looking like. So in the second diagram, we are carrying out filtration as follows. So we shall have our beaker. We need another container that will carry the filtrate. And then here we shall have our filter funnel like that. And then here we shall have a mixture of the whatever we shall obtain in the first diagram here. That's what we shall transfer into the filtration part. So this will be our filter funnel. Then this is where we shall collect our filtrate. So the filtrate will be collected here. Remember, we have said from the procedure we are carrying out filtration to remove excess or unreacted zinc. So the unreacted zinc will be left here in this filter funnel. Of course, it's going to remain on the filter paper that we are using. So that's how we shall separate the filtrate from the unreacted zinc. So after which, you now transfer this filtrate onto an evaporating dish and carry out evaporation. So we shall need our source of heat, the usual one. We have a stand, we have a tripod stand, then we have the source of heat. So this is the source of heat, and then we shall put our evaporating dish here. Then the evaporating dish will contain the filtrate, and remember the filtrate is a zinc sulfate solution coming as a result of reaction between zinc and sulfuric acid. Of course, don't forget we are going to have our wire gauge here, because just to hold that evaporating dish in position. So this is our filtrate there. Then this is our evaporating dish like that. So we carry out evaporation. Remember, we have said as you carry out evaporation, you should take note when the solution is ready to form crystals. And how do you know that? By simply dipping a clean glass rod into this saturated solution, and then you hold it in the air and then allow it to cool. Once it cools, you observe the glass rod. You'll see crystals on the glass rod. That means the solution is now ready to form crystals. Then after that, you remove it from the source of heat, and then you allow the salt solution to cool. After cooling, it will form zinc sulfate crystals. So we are saying we have prepared zinc sulfate by actually carrying out a reaction between zinc metal. So this will be the reaction, Lana, this will be the reaction. So the reaction will be as follows. Remember, in this beaker, we are having zinc combining with sulfuric acid. So when you're writing an equation, take note of the state symbols. They are very important. So this will give you which products. So our products will be zinc sulfate, which will be in solution form. That's why we are having it as a filtrate. So the salt formed here will be in form of solution. That's why we are putting aqueous and then plus hydrogen gas. So that is in essence the reaction that is taking place in this beaker here. Reaction is between zinc and sulfuric acid. We get zinc sulfate and hydrogen gas. So the zinc sulfate is the filter that we are having here. Now that we want to obtain solid zinc sulfate, then you have to carry out evaporation. Once you evaporate, you'll drive out the water, and then you'll be left with the zinc sulfate crystal. So this is one method of preparing salts, by carrying out a reaction between a metal, which is zinc, and a dilute acid, which is sulfuric acid. So we need to know this, learner, that we have other salts which are prepared, which can be prepared by this method. So let's mention just a few. We have quite a number, but we can mention a few. So other salts are prepared by this method. Include the following. We have zinc nitrate. We have zinc nitrate. We also have zinc chloride. We have lead nitrate. We can still have lead chloride, and so on and so forth. They're quite a number. These are just a few where we're reacting a metal and an acid. So having said that, let us see in form of an equation how can we prepare these salts that I've mentioned here. We want to see it using an equation. Remember, equations are very important as far as examinations are concerned. So we want to write using an equation how zinc nitrate is prepared. From the name zinc nitrate, it means you can be able to tell the acid we are using. So from the word nitrate, it means we are using nitric acid. From the word chloride, it means we are using hydrochloric acid. From the word nitrate, once again, we are using nitric acid, and then here we are using hydrochloric acid. So let us see in terms of equations, how do you prepare zinc nitrate? So zinc nitrate is prepared by reaction between zinc and nitric acid. So zinc and nitric acid, the procedure is the same. You take the acid, you put in a beaker, and then you add zinc powder until it is in excess. You'll get a salt, and that salt is called zinc nitrate. Zinc nitrate, that's how we write zinc nitrate, plus hydrogen gas. Zinc nitrate plus hydrogen gas. So anytime you write an equation, always remember to balance. So this equation of ours is not balanced. We have to balance it. As you can see, we have one atom of zinc on the left and one atom of zinc on the right. That means zinc is balanced. Next, you check hydrogen. I'm having one atom of hydrogen on the left hand side of the equation. This side has 2, so I have to make sure there are 2 on both sides. So I have to put here, I multiply this part by 2. So that will mean I'll have 2 atoms of hydrogen on the left and then 2 atoms of hydrogen on the right. Then nitrogen atoms, I'm having 2 atoms of nitrogen. I'm also having 2 atoms of nitrogen on the right hand side. Lastly is oxygen atoms. This is 2 times 3, you'll get 6. 3 times 2, you'll get 6. That means the equation is balanced. Preparation of zinc chloride, we react zinc with hydrochloric acid. This is another example where we are reacting acid and metal. You still get a salt and hydrogen gas. So our salt that will be formed will be zinc chloride plus hydrogen gas. Once again, you check if it is balanced. We are having 1 atom of zinc, 1 atom of zinc on both sides, 1 atom of hydrogen, 2 atoms of hydrogen. So we balance, we put here 2 like that. So it will mean I have 2 atoms of hydrogen on the left, 2 atoms of hydrogen on the right of the equation, 2 atoms of chlorine on the left of the equation, 2 atoms of chlorine on the right of the equation. That means the equation is balanced. Lead nitrate, we prepare it by reaction between lead metal and nitric acid. Lead metal reacting with nitric acid, we shall get lead nitrate, aqueous, it will be in solution form, plus hydrogen gas. So this will be our 2 products. Don't forget to balance. So we balance by putting here 2. Lastly, preparation of lead chloride involves the reaction between lead and hydrochloric acid. So lead reacting with hydrochloric acid, we shall get lead chloride plus hydrogen gas. So don't forget to balance once again. So you check each atom. Lead atoms are 2 on the 1 on the left, the right has 1. So lead is balanced. Check hydrogen atoms. Here I'm having 1 atom of hydrogen. Here I'm having 2 atoms of hydrogen. So I'll multiply this one by 2 like that. So I'll have 2 atoms of hydrogen on the left, 2 atoms of hydrogen on the right hand side. And then chlorine will be 2 atoms. This is now 2 atoms. So the equation is balanced. So now we are saying that these are just some of the salts: zinc nitrate, zinc chloride, lead nitrate, lead chloride, which are prepared by the reaction between an acid and a metal. We have quite a number of salts which can be prepared by the same method. So we have come to the end of our lesson. Remember, we have learned about reaction between an acid and a metal as a method of preparing salts. We have learned and said an acid reacts with a metal to produce a salt and hydrogen gas as the only product. So I want you to try to answer the following questions. Try and answer these questions to see if you have gotten the concept well. So these are the questions which I want you to look at. Questions. So our first question is as follows. The first question is why was excess zinc powder used? Why did we use excess zinc powder? Remember, we mentioned in our procedure and we saw a reason. You can try that. Second point, second question is why was filtration? Why was filtration necessary? Why was filtration necessary? We also mentioned it in the procedure. you can give, should be able to answer that question. And then our last question is then you also try this one, calcium and nitric acid. So try writing equations for these two reactions. They still fall under preparing salts by reacting an acid and a base. So we have come to the end of our lesson for today. I'll see you next time. Thank you.
Hello learner, welcome to Manifested E-Classes. My name is James Kenyani. We are going to have a physics lesson. In this lesson, we are going to solve questions on measurement 1. The objective is for us to solve questions on measurement 1. The objective of this lesson is for the learner to be able to comprehensively solve questions on this topic. So the objective is for the learner to be able to solve questions on the topic. So without wasting time, we shall go to the first question. We have question 1. So we have the first question on the board. The dimensions of the top of a coffee table are 400 millimeters by 30 centimeters. Calculate its area in A, centimeter squared, B, meter squared. So we shall go to the solutions. So the first thing we should know, they are talking of area. You should know the formula for getting that area. So in A, area is equal to length times width. Length times width. So when we go to that question, the dimensions are 400 millimeters by 30 centimeters. So we shall substitute there. This looks to be the length. So we have 400 millimeters multiplied by 30 centimeters. But before you go to the next step, in A, they are telling us we should get that area in square centimeters. So the length is given in millimeters. So it means you should convert the millimeters to centimeters. So we know 1 centimeter is equal to 10 millimeters. So it will go without saying that when we have 400 millimeters, it will be equal to 40 centimeters. So we shall substitute the right value there. So this will be 40 centimeters times 30 centimeters, and our answer will be 1,200 square centimeters. That is the first solution. We go to the second, B. B. When we go to B, still the area will be given by area will still be length times width. Area will still be length times width. So, but they want you to calculate the area in meter squared. So you still come and just substitute 400 100 millimeters times 30 centimeters. But when you look there, the area should be given in meter squared. So you should know 1 meter is equal to 100 centimeters, and also 1 meter is equal to 1,000 millimeters. So you'll convert this. So this will be the same as having 400 over 1,000 meters times 30 over 100 meters. You've converted those dimensions to meters. So you'll come and have here 0.4 meters times 0.3 meters. So the answer will be 0.12 meters squared. Alternatively, there is another alternative. And the other alternative will be, alternatively, convert the answer of A to meter squared. The answer of A to meter squared. So we know 1 centimeter is equal to 0.01 meters. 1 centimeter is equal to 0.1 meter. So when we come here, 1 centimeter squared will be equal to 0.01 meters times 0.01 meters. This will give us 0.0001 meters squared. Therefore, 1,200 centimeters squared will be equal to 1,200 times 0.0001 meters squared. So we shall culminate to having an answer of 0.12 square meters. So that is the second alternative. So without wasting time, we can go to the second question. We can go to the second question, where we have question 2. Question 2. So we go through the question again. On a sunny day, a tree next to a flag post casts a shadow of 8,400 millimeters. The flag post casts a shadow of 120 centimeters. So the question is, if the flag post is 1.8 meters, estimate the height of the tree. So the first thing we should put into mind, it's about the proportion. The shadow casted by the tree is proportional to the shadow casted by the post. The shadow casted by the tree is proportional to the shadow casted by the tree. So in the solution, because of that proportionality, we shall say height of tree, height of post We can put it that way, over height of tree should be equal to shadow of post divided by height of post, not shadow of post. So the proportionality should be in that way, height of post, this should be height of post over shadow of post. This should be now be tree. Sorry. Height of tree over shadow of tree. So that is the proportionality. So we'll come to the question and we know what is given there. The height of post, estimate the height of tree. So in the question, the height of the post is given. The height of the post is given. So you look, is the shadow of the post given? So when you go to the question, on a sunny day, a tree next to a flag post casts a shadow of that. The flag, so you realize the height of the post is given. So you'll come and say 1.8 meters divided by 120 centimeters. The height of the tree is not given. You can just height of the tree over the shadow of the tree, which is given as 8,400 millimeters. So we realize the units are not the same. So the next thing, you should convert the millimeters and the centimeters to meters. So we create space here. So before you convert, you can put this at the subject. You can write the height of the tree, by cross multiplication. It will be 1.8 1.8 meters times 8,400 millimeters divided by 120 centimeters. But now we have meters, centimeters, millimeters. So you have to convert these to meters. So you'll say 1 meter is 1,000 millimeters. We know that. Therefore, 8,400 millimeters will be equivalent to, you'll divide, you'll get 8.4 meters. You'll also come here, 1 meter is equal to 100 centimeters. So if you have 120 centimeters, you divide 120 divided by that, you'll get 1.2 meters. So as you substitute, you'll substitute the value in meters. So the height of the tree will be equal to 1.8 times 8.4 over 1.2. So lucky enough, 1.2, there once 1.2 goes there 7 times. Working that correctly, we shall get the height as 12.6 meters. That will be the height of the tree. We shall go to the third question. So that is another question there, Lana. We have in an experiment to estimate the diameter of a cylindrical wire. I think you know that shape. A thin thread wraps around the cylinder exactly 30 times. So if I'm talking of that a cylinder, the thread wraps 30 times. Calculate the circumference and also the radius of that cylinder. So we go to the solution. We go to the solution. Solution. So in the solution, we have a cylindrical wire. So you are told the thread wraps around. If you have that as the thread, that's just a picture to show it. Wraps around 30 times. So the circumference will be given by the length of the thread divided by 30. Because if the thread goes round once, that is exactly the circumference of that wire. So that's why I'm dividing by 30. So you are told, so there is some input here. If the length, given that the length of the thread is 13.2 centimeters. So you are given the length of the thread is 13.2 centimeters. So you'll come here and say 13.2 divided by 30. That will work to 0.44 centimeters. That is the circumference of the wire. So when you come to the second part, you know circumference is equal to twice pi r. Twice pi r, you'll get the circumference. So the radius from that equation, the radius will be given by the circumference divided by twice pi. The circumference divided by twice pi. So luckily enough, we have that circumference. So this will be given by 0.44 centimeters divided by twice times 22/7. We know pi is 22/7. So this will work to 0.44 centimeters divided by 44/7, which will work to 0.44 centimeters. 44 centimeters times 7/44. 7/44. So that is 1. That is 0.01. This works to 0.07 centimeters. That is the radius. That is the radius. So with those 3 examples, I'll also give right very fast an assignment you'll go and work, and we shall solve in the next lesson. So that is the assignment. The first question, in a school milk program, 24 liters of milk is distributed to students in packets of 500 cubic centimeters. How many students missed milk in a class of 50 students? The second question, a sphere of diameter 42 millimeters is remolded into a uniform cylindrical wire of, so there is something there, of diameter, of diameter 42 millimeters. Calculate the length of the wire in meters. The third question, state the three differences between mass and weight. So at that point, thank you for the audience, and let's meet in the next lesson as we continue working on further solution on this topic, measurement 1. So thank you and have a good day. Bye.
Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Welcome to Manifested e-learning. Today we are having a lesson in history and government, and we are continuing with our topic on introduction to history and government, and specifically we are looking at the sources of information to history and government. So in our previous lessons, we looked at the categories of sources of information to history and government. So my dear Lana, can you be able to remember the categories in which we categorized these sources of information? The categories. So we said there are 3 categories of information, right? So we said there are 3 categories of information. So can you remember them? Number 1, which we have already looked at, are unwritten sources. Unwritten sources. And my dear Lana, can you remember the unwritten sources that we have already discussed in our previous lessons? Yes, I'm sure you are able to discuss. We discussed 5 of them. Can you be able to mention them? Yes, you can tell your friend there, your brother or sister. Yes, which are these unwritten sources? Yes, we looked at oral traditions. And then number 2, we looked at what else? Linguistics. Which other one did we look at? My dear Lana, which other one? Archaeology, very good. Archaeology. Which other one did we look at? There are still 2 that we have not mentioned. Yes, very good. Anthropology. And then lastly we looked at genetics. So my dear Lana, you should be able to remember these. What do they mean? What do these terms mean? And what are the advantages and disadvantages of using each source of information? So which are the other 2 categories of information or sources? So we have to look at the other 2. So we said the other 2, or the second one is written sources. And then number 3, we have electronic sources. So my dear Lana, we have already looked at the unwritten sources. Now today, in our lesson today, we are going to look at these remaining 2, written sources and electronic sources. So by the end of this lesson, These are the objectives I want you to be able to achieve. Objectives for this lesson. So by the end of this lesson, my dear learner, you should be able to identify, right? Identify the written sources of information. All right? That is the first objective or the first goal I want you to be able to achieve by the end of this lesson. And then number 2, you have to outline the different electronic sources of information. The different electronic sources of information. So to start us off, let us look at the number 2 category of sources of information. Remember, we are talking of categories, and written, we have written and electronic. So number 2, let us look at the written sources of information. That is what we are discussing. Written sources. Written sources. So when you talk about written sources, these entails information that is written down in any form, as long as it is written down. It can be in form of a writing, it can be in terms of a painting, right? That as long as it is recorded down, that is a written source. So when we talk of written sources, it involves every kind of information as long as it is written down. It does not matter wherever it is written, whether it is on a wall, whether it is in a book, whether it is on a stone, it has to be written down, recorded down using a specific manner. It can be an engraving, right? It can be a painting on a wall, right? That is a written source. So when you talk of written sources, right, it means it is recorded down. So today, how do we record down? For example, the information that we are learning right now, right? You are taking notes on your book, right? That is recording down. That is a recorded information or written information, such that even when you are old, you have become a grandpa or a grandma, right? You can be, if you are able to find that book, you will get the information that you learned in this lesson, right? So there are different ways of writing or storing information. Before the writing of paper, because today we write on paper, right? We write on paper for you to record information. How do you think before the writing of paper or invention of paper came and using the modern pen, right? How are people writing down? How are people recording information? Yeah? How do you think they were recording information? So there are different ways in which they were recording information. So these could be in earliest times. In the earliest time, let us first look at the earliest times, right? In the earliest times, before the invention of papers, right, came, people are writing down on tablets, stone tablets. That is where information could be written, and it is important information. For example, in your CRE, or you have heard the story of Moses and the 10 commandments, right? So at that time, there was no paper, right? So God decided to write his commandments for the children of Israel on a stone tablet, right? So on a stone tablet, we call that engraving because you have to use some kind of a metallic object to write on that stone, right? So the writings are engraved, right? They are engraved on a stone, or you have to chop. If you are drawing an image, you have to chop the stone, right? In other places, there was paint. Yeah, in some cases, there was using of paint, right? So those were the earliest. The other one, or the other earliest example, A, we could talk of A. B, there was something else that was known as parchments. Parchments. So this is where you find in the ancient times, a skin of an animal could be dried, right? And then scrubbed. Then on that, there is use of paint to write information, to record. Most of the time, you could find they were recording names of the leaders of at that time, right? Or important events. For example, a victory in a war could be noted down in parchments. These were skins that were dried and then written on, right? And then number C, we had scrolls. We had scrolls. This was a kind of reeds that could produce a very long sheet, right? A very long sheet that looked like a paper, right? And then on this scroll, information could be written. So you could write as you unscroll. So imagine we are having, I wish I could have that. Imagine this, you could have a paper that is tied down on these two, these could be sticks, and then it is tied on. So if you want to write, you have to scroll, and then you have to paint on the scroll, right? Yes, you could check up on the internet, you could find examples of scrolls. Now, when we come now to the modern times, right? So when you come to the modern times, yeah, just before we look at the modern times, you could have paintings. Yeah, before we come to the modern times, number D, we could have paintings. Paintings on caves and rocks. Paintings on caves and rocks. So you could find people storing information about what they are hunting, right? What are the animals they hunt? They could paint them in the caves they were living in, or on rocks where people could pass by. So that was another form of storing information. So let us come to the modern times. The modern times. The modern times. How do we now store information today? How do we record down information that is written down, right? We have examples, we have books, like the exercise books you are having. We have journals. Journals. Each and every day, somebody could be recording. Like today, my day was this and this. I went to such and such a place. I found this and this a person. That is a journal. Journaling down the events, the daily occurrences, right? That is a journal. We have diaries, right? Diaries. You have, for example, if you have so many clients, you have to make appointments on diaries. That is a diary. So if you find, for example, if you want to know the activities of a president, for example, where he is supposed to go or where he has been going, just go and find the diary. You will find the president on this day, at this time, he met so and so. That is a diary, right? Yes, we have other sources. We have newspapers. Newspapers. Yes, we have newspapers. Can you mention the newspapers we have in Kenya today? The different kind of newspapers we have in Kenya today. We have the Standard newspaper, very good. We have the Daily Nation, very good. We have the Taifa Leo, very good. Which other newspaper do you know? We have the Business Daily. That's a newspaper that is happening. The East African newspaper, right? So these newspapers, it provides information or news, the current news that is happening in the in the country or in the world today, you will find it from newspaper. So even 10, 20 years to come, if you want to know what happened today or in the year 2020, you just need to go to a media house or somebody who has been stocking the newspapers for each and every day. You'll be able to know what was happening at that time. So that is a newspaper, and many other forms that we cannot exhaust. The written forms are so many. You have you have talked of newspapers. We have talked of magazines, right? Magazines, right? We have talked of magazines. Yeah, we have talked of magazines. You could find specific series happening each and every time. So these are just written down. They are paper that you could see. Somebody has recorded an information that is happening. So you have to find these things. Huh? Another example that I can remember, you have a periodical. Periodicals. So this is an example of, you can talk of a pullout or a writing that is done over an individual over an interval of time. That is a periodical. Maybe it is written once every week or once every month or after every 3 months. That is a periodical. So you can find out which are other modern forms of written information. So what are the advantages and disadvantages of using written sources of information? So quickly, let us look at the advantages. Advantages of written information. Advantages of written information. Advantages of written information, right? So number one, information is more accurate. Information is more accurate. What does that mean? For example, if you are having a newspaper, right? A newspaper will record the events as they are occurring, right? So if an editor is writing down what is happening today, for example, we are having the case of locust invasion, right? The newspaper will record where that information or where those locusts are. If, for example, it is a diary, somebody has an appointment, a CEO of a company has an appointment. It is an appointment with a specific person, right? So once it has been written down, right, without rubbing, you will be able to know that is the accurate information, and you are able to compare one written source with another. For example, one newspaper with another newspaper. That brings accuracy. Information is more accurate compared to other sources. For example, anthropology, where it requires just the researcher to make a conclusion. And then, number two, the information or the source is cheaper. It is cheaper to pass mass information. It is cheaper to pass mass information. So if you want to pass information to a large audience, right, it is easier compared to genetics. Very few people will understand the characteristics of a human being that are passed from a parent to a child. But when you are having a newspaper, for example, a lot of people can be able to read the newspaper. That is the other advantage, right? And then number three, information can be translated. Can be easily translated. Information can be easily translated into other languages. For example, if you have a book that is written in Swahili, it is very easy for that book to be translated into English and vice versa, as compared to information that is you get from oral traditions. It will take you a lot of time to get one explanation of a legend from one group of a person, you go to the other one, they might be giving you different information. But now for a book, it is written down. So it's a matter of you translating a sentence after the other. And then number 3, information can be stored. It allows future reference. Future reference is possible. Because information is written down, you are able to, even 10 years to come, to peruse through and know this is what was happening at that time. What are the disadvantages? What are the disadvantages of using these kind of a source? Disadvantage or a limitation. What are the limitations? Or we said another term that can be used here is a shortcoming. What are the disadvantages, right? So the biggest disadvantage of written sources is it's only limited to those people who can read and write, right? It is only limited to literate people. That means only those people who are able to read and write. If you are not able to read, you cannot get information from a newspaper, right? If you are not able to write, you cannot fill out a journal for yourself, right? So this information is only limited to those people who are literate, right? And then we say the writer. Number 2, the writer can omit information. The writer can omit information. Take an example of a journal. You only write that which is exciting to you. You might want to omit another. You might want to omit information that is not conducive for you, right? And then number 3, the reader. The reader might misinterpret the information that is written down. The reader might misinterpret the information that is written down. That is another limitation. And then lastly, the writer. The writer might be biased. The writer must be biased. A very good example is the newspaper. Let's say we are having, remember when you are having political situation, or when you are having politics in our nation, you might find the Standard, for example, as a newspaper, decides to report what, for example, when you are having the last elections, what the NASA team is doing. And then the East African will decide to concentrate on what Jubilee is doing. So if you are just reading the Daily Nation, you are not able to know what the other thing or what the other team is doing. So my dear learners, we have been looking at the written sources of information. So as we come to the end of our lesson today, I'm sure you have been able to discuss what written sources of information are, right? So I want to give you an assignment that you are going to attempt, right? That you are going to attempt in your books. So you can write down these questions. Revision questions. Revision questions. So number 1, very easy questions. Name the earliest written written sources of information. Name the earliest written sources of information, right? And then number 2, explain the disadvantages of relying only on written sources of information. On written sources of information. So number 1, name the earliest written sources of information. That is the first question. And then number 2, explain the disadvantages of relying only on written sources of information. And my dear learner, we have already discussed this, and as I always encourage you, try to write the answers and then you can confirm from the notes that you have taken, or you refer back to the lesson that we have had. So until our next lesson, it's bye-bye.
Hello learners, do you find yourself sometimes having problems with tenses, that you perceive tenses as being a difficult subject to understand? So in this lesson, I'm specifically going to simplify the tenses in English for you. I'm going to give examples of sentences, explain the form, and explain the different types of tenses and their uses to make it more simpler for you. So welcome to Manifested Online Classes. In this lesson, I'll be taking you through the simple present tense, to be specific. So in the last lesson, we had talked about verbs, types of verbs, and I also gave some work for you to do. I hope you've done that work. So before you continue with this video, make sure that you complete the last lesson's assignment. So first, I will begin with talking about the tenses in general before we narrow down to the simple present tense. So in English, we have 3 times. That is, we have the past. I'm going to use a line to try and explain better. So we have the past, then at the center here we have the present, and then we have the future time. So it is these times that actually dictate the tenses. So because I'm sure you have heard about the past tense, you've heard about the present tense, and you've also heard about the future tense. And then we further have something that we call the aspects. So we have 4 aspects. First, we have the simple aspect, and then we have the continuous. We have the continuous aspect, then we have the perfect, and then we have the perfect continuous aspect. So it is this aspect together with the times that are combined to form the 12 tenses that we have in English. So in total, we have 12 tenses in English. So by the time you're done with the English grammar lessons here at Form 4, you will have gone through the 12 tenses that we have in English. But in this particular lesson, I want us to talk about the simple present tense. So it is the aspects that combine with the times to form the different tenses that we have. So in this lesson, I've said we will specifically talk about the simple present tense. So as the time, this one present suggests, the present tense talks about the things that are happening in the present. So the one aspect or the one aspect of structure that dictates the tense is actually the verb. You remember we talked about the parts of speech, and we mentioned the verb as being one of the parts of speech. So it is the verb that dictates the tense in which a sentence is in. So how do we start first with the form. How do we form the simple present tense, sorry. So the simple present tense is simply formed by a subject plus a verb. So at this point, I think all of us understand what a subject is. So basically, the subject is that part of the sentence that performs the action that is described by the verb, or it is the main topic of a sentence. So let me give an example of a sentence. So for example, I say, I drive. Or we have another one, she drives. So she and I here, which are pronouns, they represent the subjects in this case. And then drive and drives here are actually the verbs in these structures. So we could add something else here to make these two sentences more complete. So we could say, I drive occasionally to school, or yes, something like, you could have a sentence like that. So in this sentence, I drive occasionally to school, or she drives to work. Now those two sentences are correct. But then there's something that you notice regarding the nature of the verb that we have used there. These two sentences could be said they are in the simple present tense because of the verb. Notice that when we have used she, we've added an S to the original verb to make it drives. So this is what happens in the simple present tense. If your subject is either I, you, or they, or we, you do not need to add an S to your verb to change it to the simple present tense. For example, you say in a sentence like, you walk to school every day. So just look at this sentence. Our subject, we've said the simple present tense is formed by a subject plus a verb. And we've also mentioned that some of the verbs are used in their natural form. For example, the verb walk here, the verb drive here. But in some cases, it may be necessary for you to add an S. But I've already mentioned that if your subject is either of these personal pronouns, either I, you, they, or we, you may not need to add an S to your verb. And I've given a good example here. You walk to school every day. We could also have if we change our subject from you to they, you realize that the subject, the verb still remains walk. So because this will still read to they walk to school every day. But what about if we were to use it? So we could have it walks. You could have something like that. It walks. You realize when we change the subject to it, the verb has changed. So if your subject is either it, he, or she, you may need to add an S to your verb so that you can form the simple present tense. So the simple present tense, just like in all other sentence constructions that you've come across, there is need for you to make sure that there is what we call the subject-verb agreement. That if this is your subject, there's a way that your verb is supposed to behave so that there is that subject-verb agreement. If your subject is in the singular or is in the plural, there's a way that your verb is expected to behave so that there is coherence and so that the sentence is also grammatically correct. So take note of that when you use either of these subjects, if you use these ones, there's need for you to add an S to your verb. If you're going to make use of this, there is no need for you to add an S to your verb. The verb remains the same. So that is how simple it is to form a sentence in the simple present tense. So now that we're done with the form, we're going to now start talking about the functions. In which instances are you supposed to make use of the simple present tense? So we're going to discuss the functions of the simple present tense. So you will find that there are many functions that have been discussed in your books, the books that you have. If you also check on the internet, try to do some research on the simple present tense, there are so many functions, but I am going to talk about the 4 main functions of the simple present tense. So there are many, but most of them have just been repeated. So I have narrowed down to the 4 main uses of the simple present tense. So we're going to start with the first. So the first one is to express or to talk about facts. So what is a fact? So a fact is those things that we cannot debate upon, that are things that we cannot debate. They are what happens. So for example, in a sentence like water boils at 100 degrees Celsius. So this is a fact. We cannot debate about this. This is what is there. Water has to boil at 100 degrees Celsius. So this is a fact. And then when you look at the nature of our verb, there, boils, we've just added an S to change this verb to be in the simple present tense. So for all those sentences that are written to express facts, we could also talk about the earth rotates, or the sun sets in the east and rises in the west. Yes, so all those things all those statements that are used to express facts are actually in the simple present tense. That is one function. And then the other function of this tense is to express permanent situations. So when you talk about a permanent situation, it's something that you cannot change. It's something that is there, but you cannot change it. It's like it's almost like a fact, but it's a situation that you're in that is permanent. For example, if I say, she lives in Nairobi. So she lives in Nairobi means this is a permanent situation. That is where she lives. So it's not like she's going to move away from Nairobi in 2 weeks or in 3 weeks. That is her permanent location. So she was going to be in Nairobi for a time that is not specified. So it's like permanently she lives in Nairobi. Also, when we look at another sentence that like she works at the airport. Also in this sentence, this is permanency. We are not saying she's working at the airport. So this when we change this verb, when we add an ing here, we change this verb to the continuous form, we change the meaning of the sentence. Because if we were to say she is working at the airport, so that means at this point she's working at the airport. So maybe tomorrow she will not be working at the airport anymore. But if we say she works at the airport, that's it. She works there, and that is what she does. So she's not going to change. She's not going to work in any other place. She only works at the airport. Then we can look at the third use. I've said I'm only going to discuss 4. So the fourth use of the simple present tense, the third, to express or to talk about habits or routines. So look at this sentence that I had given here. You walk to school every day. This is like an habit or a routine. So every day you have to get up and walk to school. So this is what I am talking about when I say to express habits. Like those things that are done on the regular. And then you could also note that we use every day. Every day, you remember we talked about parts of speech, and we talked about the adverbs, and I think we also talked about the different adverbs that we have. So every day here is actually an adverb. So to show that that is something that is done is almost like a routine. Then we could also have another sentence like she wears the dress on Mondays. So this means that she has a special dress that she has to wear every Monday. So on every specific Monday, she wears that particular dress. So it's an habit. So she has to do it every Monday. So any habit or any particular routine, like she goes to work at 10 o'clock. So that means every other time at 10 o'clock, she has to be at work. So that is like a routine, or it's like an habit. A routine, something that she has to do every other time. So you will also notice the nature of the verbs in our sentence. We have wears, we have work, and remember what we have said about the subjects. So it is the subjects that will dictate the nature of your verb in the simple present tense. And then we go and we talk about the last use to talk about careers. Yes. So when you say she is a teacher, he is an architect, he is a psychologist, all those is there. The verb is, when you say she is a teacher, Mary is a doctor. So in these two sentences here, we have the verb is here, but it is used to tell us about what she does, their occupation, not basically talk about the occupation. So she's a teacher, Mary is a doctor, so that is what they do for a living. So that is the other use of the simple present tense. So I have said when you look at your books, you may have more uses than what I have discussed here. So I have just narrowed down to the main uses of the simple present tense. If you get time to check up on the net, you will also be able to get more uses of the tense, but these are the main uses of the tense. So if I were to go back to the lesson to just look at what we've talked about, we were basically talking about the simple present tense. However, I have mentioned that we have 12 tenses in the English language, and we've talked about the times. We've said we have 3 times in the English language, that is the present, the past, and the future. So the tenses are derived from the times and the aspect. Remember, I've also mentioned that we have 4 aspects in the English language. So it is the aspect and the time that are joined together to make up the 12 tenses in the English language. So we have started with the basic tense. That is the simple present tense. It's the simplest as the most basic tense in English. So I've talked about the form, how we form the simple present tense. So I've said you must have a subject plus a verb for you to be able to form the simple present tense. I've also mentioned that it is the work of the verb to denote the tense. So you change the verb to, if you want to change tense, the tense of a sentence, you change the verb, because it is the work of the verb in a sentence to show or to denote tense. So I've given the different forms. I have also talked about the different subjects and how the verb changes for each of the subjects. So we've said if your subject is either I, you, they, or we, your verb is, you do not need to add an S or ES to your verb. The verb remains the same. So I've given an example of a sentence here. You walk to school every day. They walk to school every day. I want you to take note of the verb. I'm not adding anything to the verb walk. It is remaining as it is in the natural point. So if we have subjects such as it, he, or she, we may need to add an S or an ES to the verb so that we can communicate. We've given an example where we have said she walks to school every day, or he walks to school every day. You can also say he goes to the market in the afternoon. Those are just examples of sentences for you to be able to see how the verb changes if you change the subject. And then we've gone ahead to talk about the different functions or the uses of the simple present tense. So we have said we use the simple present tense to express facts. And I've mentioned that facts are those things that cannot be argued about, cannot be debated upon, like that is just it. That is the truth of the matter. So you could also have, and then we've talked about express permanent situations. So I've also said permanent situations are those situations that cannot be changed, like they have to remain the way they are. And then we have also talked about to express habits or routines. So you said an habit or routine is something that is done maybe on a daily basis or on a specific day. Like you have a routine. Every Monday, you must go to church. Every Tuesday, you must visit your mother. Every Wednesday, you must discuss mathematics in your groups, or you must see your mathematics teacher. Something that you do that has a defined routine. So you use the simple present tense to express that. We've also talked about careers or professions. So when you want to talk about your profession or the profession of your parent or whoever, you make use of the simple present tense. So remember, this is the most basic tense in English. So it is important that before you move on, you make sure that you understand the uses, you understand how this tense is formed. Because if you do not do that, it will be difficult for you to understand the other tenses. So I want to give some work for you to do so that you can try and see whether you've understood what we've talked about. So you're going to make sure that you attempt the exercise. So for you to be able to attempt the exercise well, you need to go back and understand that what we've talked about, that if your subject is what you've talked about, the subject and the verb agreement. Because in the following sentences, we've given you verbs for you to change them in the most appropriate form so that you can construct the sentences. So make sure that before the next lesson, you attempt doing the assignment so that you can correct yourself where you go wrong. Everything that can assist you to answer this exercise is within your notes or is what we have been discussing throughout the lesson. So we've come to the end of the lesson. I wish you all the best. Make sure you practice a lot using the tense, communicate to your parents, communicate to your peers using the language. Then it will be easier for you to understand. Also, this is a very brief exercise, so you can still source out some more sentences for yourself, some more exercise. Remember, practice makes perfect. So until the next lesson, I wish you all the best. Goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and today we continue with our topic, and our topic of discussion is acids, bases, and indicators. During the last lesson, we discussed the commercial indicators and the colors they give in different solutions. So we saw some solutions are acidic, they give a particular color with a particular acid. Other solutions are basic, they give a particular color with a particular indicator. So today we are going to discuss another indicator that is known as universal indicator, and we are going to discuss it together with what we call the pH scale. So universal indicator and the pH scale. Now, unlike other commercial indicators that we discussed in the previous lesson, we have another indicator that is called universal indicator, and this one is usually a mixture of several indicators. is usually a mixture of several indicators, and it's the only indicator that tells us whether a solution is a strong acid or a weak acid, or whether a solution is a strong base or a weak base. All the other indicators that we have learned before, they were showing whether a solution is acidic, full stop. But they were not going ahead to inform us whether that acid is a strong or a weak acid. But for the universal indicator, this one answers that question. So it gives different colors with strong acids and different colors with weak acids, different colors with strong bases and different colors with weak bases. So you can say that universal indicator is a mixture of several indicators and is used to tell the degree or the strength of acidity or basicity. So it's the only indicator that tells us the strength or the degree of acidity or basicity. So universal indicator is used together with the pH scale. Can say that it is used together with a pH scale. With a pH scale ranging from 0 to 14, depending on the strength of acids or bases. So we'll have an illustration of the pH scale. Is a scale that ranges from 0 to 14. 0 to 14. Between 0 and 7, that's the middle. Of course, here we have acids. We have acids there. Between 7 and 14, we have bases. And then at exactly 7, we have neutral. When something is neutral, it means that it is neither on the base side nor on the acidic side. Then it has values, pH values, 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 13, 14. So at pH value between 1 and 4, 1, 2, 3, up to 4 here, these are strong acids. Up to 4. Between 4 and 7, these are weak acids. So as the acids near the pH of 7, which is neutral, they become weak. Also, the bases 8, 9, 10, as they near the neutral, they are weak bases. But as they move away from the neutral, that is 11, 12, 13, 14, these ones are strong bases. Yeah. So this is a pH scale showing the strong acids that have a pH of between 0 and 4, in between there. So it can be 1 2, 3. That's a strong acid. If it is 5, 6, those ones are weak acids. If their bases are 8, 9, they are weak bases up to 10. The strong bases are 11, 12, and 13, all the way up to 14. So those ones are the way you tell whether. So we have the strong acids up to there, bases up to that, then finally up to that. So we have the pH scale helping us to know that these acids are strong or weak. Now, where does this value 1, 2, 3, 4, 5 come from? The universal indicator is used together with the what we call the pH color chart, or the universal indicator paper. And that paper has different colors, and each color has a pH value. So if you get a color, for example, that is red, you may find the pH value there is either 1 or 2. If you get a color that is orange, the pH value will be 3. So we can say that universal indicator is used together with a pH color chart. With the pH color chart having different colors and corresponding pH values as shown below. So we'll still have the same pH scale from 0 to 14. The midpoint is 7. pH 1, 2, 3, 4, 5, 6. So if the pH is 1, 2, 4, 5, so we are drawing another pH scale showing the different colors. So pH of 1 and 2, the color is red. The pH of 3 and 4, the color is orange. And the pH of 5, 6, the color is yellow. At exactly 7, the color is green. So we have different colors on the color chart showing the different values. So value of 1 and 2, the color is red. That's a strong acid. 3 and 4, also a strong acid, but pH 3, yellow, the color is, the pH is a 5 or 6, that is a weak acid. So we can use it together with that. So 8, 9, and 10, here the color is blue. And then 11, 12, the color here is purple. And then above 12, the color is violet. So that is the pH scale showing various colors on the color chart. So various colors on the color chart. So if the color is red, it's a strong acid. If the color is yellow, it's a weak acid because it's 5,6. If the color is green, it's neutral. If the color is blue, weak base, purple and violet, strong bases. So we are saying that the universal indicator is used together with the pH color chart. Each indicator has a color chart that shows the pH values. 1 red, 2, 1 and 2 red, 3 and 4 orange as shown there. So these ones indicate the value. So the higher the pH value, the weaker the acidity or the weaker the acid. The higher the pH value, the stronger the base. So you can say that from the above, pH scale, we can conclude that 1, the higher the pH, the weaker the acid. The weaker the acid. Because we can say that strong acids have low values, weak acids have higher values. So the higher the pH value, the weaker the acid, and vice versa. In bases, the higher the pH, the weaker, no, the stronger, sorry, the stronger the base. As we can see, bases, strong bases have higher values, weak bases have lower values. So the higher the pH, the stronger the base, and vice versa. So an easier way of telling whether an acid is strong or weak, as you move closer to 7, the acid becomes weak. As you move closer to 7 on the base side, also the base becomes weak. So as you move towards 14, the bases become strong. As you move towards 0, the acids become strong. So you can also say that in this direction, we have increasing acidity. And on the other side, we have increasing basicity. So we have that. So at that point, we can have an assignment on the universal indicator and the pH scale, as we have explained. So the assignment, the first question, what is universal indicator? 2, how is universal indicator different from other commercial indicators? Number 3, determine whether the following solutions are neutral, strongly acidic, weakly acidic, strongly basic, or weakly basic. So we have solution X, Y, and Z. The pH value is given. So you're supposed to say whether it's a strong acid or a weak acid, or a strong base or a weak base, or is neutral for each one of them. So we'll stop there. Until next time, goodbye.
Enroll your child for the Manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Welcome to Manifested e-learning. Today we are going to have history and government lesson, and as we have been looking at the topic introduction to history and government, and specifically we have been looking at the sources of information to history and government. So a quick overview, my dear learner, of what we have learned in our previous lessons. We categorized the sources of information in history and government into 3 categories, right? Can you remember the 3 categories? Yes. We had 3 categories. We had the categories of sources, categories. We had three categories. Number 1, unwritten sources. That is number 1. And among the unwritten sources, we mentioned 5 unwritten sources. Can you remember the 5 unwritten sources? We had oral traditions. Then number 2, what else do we have as our next source? We had linguistics. Number 3, what else do we have? We had archaeology. And then we had, as number 4, anthropology. And then lastly we had genetics, right? So that was among the unwritten sources, and we said these are not recorded down, right? Yeah. And then number 2, we looked at written sources. We looked at written sources. Which were the written sources? We looked at the earliest written sources. We mentioned the stone tablets. We mentioned the scrolls. We mentioned what else did we mention as an example of a written? We mentioned the scrolls, the stone tablets, and the parchments, right? And then we mentioned the modern. So here we talked of earliest forms of written sources, and then we had the modern written sources of information. Here we mentioned newspapers, we mentioned periodicals, we mentioned magazines, we mentioned books, right? All those are under modern methods of written sources. And then number 3, the third category, which we are going to look at in our lesson today, we shall look at electronic sources. So that is what we are going to discuss in our lesson today. So having had an overview of what we have already done, so we come to today's objective. So what are we going to learn today? So by the end of the lesson today, my dear learner, I want you to be able to identify, right? Identify the electronic sources of information. That is the first objective. And then number 2, you should be able to explain the advantages and disadvantages of what? Electronic sources of information. So let us look at the electronic sources of information. So that is number 3, electronic sources of information. Remember, my dear learner, I do not want you to forget this. We talked of categories of information. We said the first one was unwritten sources. Note that very well. It is a category, not a source of information. It is a category of information or sources of information. And then number two, we looked at the written sources of information as a category of sources of information. And then now we are looking at the electronic sources, right? So when you talk of electronic sources, they can be divided into three. Electronic sources can be divided into three. So they are divided or grouped into three. They are grouped into three. So number one, or Roman 1, we shall look at audio sources, right? Audio, right? And then number 2, we shall talk of visual sources. And then number 3, we talk of audio visual sources. Audiovisual sources. So, electronic sources. When you talk of electronic, these are instruments, or it's a source that uses or is connected to an electrical source for it to function. So, the first one, let us look at audio sources. Audio. That is Roman 1, audio. When you talk of audio, right? Audio. Audio has to do with sound. It has to do with sound. You can hear, right? You can hear. So audio sources are those sources that have been recorded electronically. Sound has been recorded electronically. You can hear somebody speaking, right? But you cannot see them. That is an audio source. Today, we are having electronic gadgets that can allow you to capture voice, right? It can allow you to capture sound, right? That is an audio source of information. For example, most of us, or of us, the younger generation, we were not able to find the former president who died, that is Mzee Moi, right? We did not see him, or we were not there when he was leading, right? But during the time or the period when he died, we could hear clips. We could hear audio clips. We could hear his words while he was still in power. How is that possible? So it is recorded in different forms, right? You could have cassettes, right? You could have radio, right? When those of us who have radio, you could hear somebody speaking. You can hear a caption of somebody speaking, right? But you cannot see them. That is an audio source. Yeah. So examples here, we can talk of radio. Radio. So you could hear somebody in a radio station speaking. You could hear they have invited a politician to the radio station. So that voice will be recorded. So even years to come, you can, if you go to that radio station, they will have clips of what has been happening. That is a record of what has happened. Nowadays, you have phones, right? You will find people going around recording people or recording voices of different things. So apart from radio, we have tape recorders. Tape recorders, right? Tape recorders. You record, right? Something as it happens, the voice, what you can hear. That is an audio source of information. Then Number 2, my dear learners, let us look at visual. Visual. So when you talk of visual source, right, this has to do with sight. This has to do with sight. You can record something that you are seeing, right? You can see things happening, right? So the most common here, you can talk of pictures. Pictures being taken. So for you to take a picture, you require a camera, you require a phone, right? That is an electronic gadget. So for you to take pictures, you need to have an electronic gadget for you to take a picture. So any kind of visual that you can see, right? You can see, or you can just record without voice, right? That is a visual source. And then number 3, we talk of audio visual. Audio visual. So this one is a mixture. A mixture of sound and picture. A mixture of sound and picture. So the best example here is like what we are having right now. You can hear me and you can see me, right, as we have the lesson. That is an audio visual. So if you record this lesson, right, from your laptop or from your phone, you download it. After you have downloaded it, you will have it in your phone or in your laptop, yeah, or in whatever form you are going to store it, right, in your flash disk, whatever form. You are going to hear some voice and you are going to see. So the best example there is what we refer to as a video, right? A video is a very good example of an visual or an audio visual. Or else we can also talk of television. Television. What you see on TV, you will see the politicians in parliament, for example, right? You will see them debating different issues, right? Right now, we are talking of floods, right? You can see how people's homes are being swept out. You could hear people talking how the houses have been swept out. So you can see the person and you can hear the voice of that person speaking. So that is an audio visual source. These are modern and they are the best because you can actually see, right, the activity as it happens and you can hear as the activity happens. So my dear learners, what are the advantages and the disadvantages of using electronic sources of information? So let us look at the advantages. Advantages, right? So the advantages, they are quite few. So number 1, we talk of it is fast. They are faster in spreading information. So if you want to get information, it is very easy for you. You just switch on your television set. You have information. So if you want to get what somebody said in some years to come or some years ago, you just need to go and get a source, or you can go to a radio station. You get what that person said. Number 2, information is easily stored. Information is easily stored. Information is easily stored. So you can capture events as they happen. Nowadays we have whatever people are calling paparazzi, right? As an event is happening, everybody has a phone. So it is very easy to capture and store information. And then lastly, excuse me, number 3, information can be transferred to long distance. Information is transferred. Information is transferred over long distance. Information is transferred over a long distance. It's very easy for you to know what happened in the US without you going to the US, right? It is very easy for you to know what is happening in Uganda without you traveling to Uganda physically. You just need to tap yourself to an electronic source. You have email, right? You have television. You could Google to get information. So information is easily transferred over a large distance. So let us look at the disadvantages as our last portion. Disadvantages. So the first disadvantage or limitation for an electronic gadget to function, it only functions where there is a source of power. So it is limited to where there is electricity. It is limited to where there is electricity. And then number 2, it requires technical know-how. Requires technical know-how. You cannot operate an electronic gadget without you having the knowledge of operating that gadget. And then it is subject to manipulation. So with modern technology, it's very easy to tamper with the original information. So you could have recorded something, but if somebody gets hold of that recording, they are able to distort or tamper with the recording as it happened, and they make it seamless. You cannot even notice. So those are some of the limitations. So my dear learner, you could go and find more advantages and disadvantages. So that is all about the sources of information to history and government. So just to have an overview of what we have been learning, we have looked at the categories. And I told you, I will repeat this again, my dear learner. We are talking of categories. So the sources of information can be categorized into 3. Unwritten sources, written sources, and electronic sources. So at no point should you, my dear learner, when you have been asked to give a source of information and you say unwritten source, that is not a source. That is a category of a source, right? Most of you, or most of learners make a mistake, pardon me. Most of the learners make that mistake. They are asked to give or mention a source of information, and then somebody answers an unwritten source. That is a category of a source and not a source. So you have to mention these sources that we have looked at. So as we come to the end of our lesson today, I want to give you a very short revision quiz, some questions that are going to help you revise for what we have looked at in our lesson today. So a revision question or revision question. Revision questions. Number 1. Number 1, identify any 3 sources, any 3 electronic sources, any 3 electronic sources of information. That is one. And then number 2, discuss the advantages and disadvantages of electronic sources of information. Discuss the advantages and disadvantages of electronic sources of information. So with that, if you are able to answer those questions, my dear learner, I'm sure you will be able to effectively tackle any problem or any question that you are asked concerning electronic sources of information. So with that, my dear learners, we have come to the end of our lesson today. Until next time, it's bye-bye.
Hello learner, my name is Dickens and we are looking at methods of preparing salts, and in today's lesson we are going to look at how to prepare salts by reaction between an acid and a metal oxide. That is what I want us to look at in this lesson. Reaction between an acid and metal oxide. That is what I want us to look at in today's lesson. So we are going to consider a brief experiment here. We are going to look at experiment. We are going to look at preparation of copper to sulfate. That will be our basis of today's discussion. So our procedure is as follows. You measure about 20 centimeters cubed of dilute sulfuric acid and transfer into a beaker. So of course we measure using a measuring cylinder, and then after that you warm the acid just for a few minutes. So the reason why you're warming the acid is simply to increase the rate of reaction. Remember, we are reacting an acid and a metal oxide. Therefore, when the acid is cold, the reaction will be very slow. So we warm the acid so that we can increase the rate of reaction. Secondly, procedure: you add copper to oxide to the warm acid. We are adding copper to oxide to the warm acid a little at a time. As you stir. Of course, we are stirring with a glass rod so that we can increase the contact between the reactants. Remember, our reactants are the sulfuric acid and copper to oxide. So we stir so that we can increase that area of contact. Thirdly, continue adding copper to oxide until in excess. So we shall add more and more copper oxide as we stir until it is in excess. So we can realize that we are using excess copper oxide to make sure that all the acid has been used up. Fourthly, you filter to remove excess copper oxide. So remember, when you carry out filtration, we shall obtain a filtrate. And remember, the filtrate is obtained as a result of the reaction between copper 2 oxide and sulfuric acid. So in essence, our filtrate will be copper 2 sulfate. So that is what we shall get after carrying out filtration. So lastly, after filtering, you evaporate the filtrate, over a water bath. So we are using a water bath to simply slow down the process of evaporation over a water bath, so that we can slow down the process of evaporation, and that will help us in obtaining large crystals. So having talked about the procedure, let us look at now the reactions that are involved here. The main reaction, we look at the discussion, we call it discussion, or the observations. So we are reacting copper oxide with sulfuric acid. This will be the expected reaction. Copper oxide will react with sulfuric acid. Remember, it is dilute. Copper oxide is a solid. So the two compounds react. We shall get two products. We shall get a salt and water. So the name of the salt will be copper sulfate, which will be in solution form. That's why we are carrying out filtration, and water. So we shall get two products. You'll get copper sulfate and water. And remember, we said anytime you write an equation, you should make sure that you have balanced the equation, and you balance by making sure that the atoms of each kind are equal on both sides of the equation. So we check copper atoms. This is one on the left and one on the right hand side, so copper is balanced. You also check oxygen atoms. This is 1 plus 4, those are 5. Check oxygen atoms on the right hand side. This is 4 plus 1, that is 5, meaning oxygen atoms are balanced. Next, you check hydrogen atoms. These are 2 on the left. We also have 2 on the right. That means hydrogen atoms is balanced. Now you come to sulfur. Sulfur, this is 1 atom, this is also 1. So it means the whole equation is balanced. So this equation is as a result of reaction between a metal oxide, which is copper oxide, and sulfuric acid. That will give you copper sulfate and water. So it's also good we mention other salts which can be prepared using the same method. Other salts prepared by the same method include the following. Same method include, there are quite a number. We are just going to mention a few for the sake of writing the chemical equations. We can have zinc sulfate. Zinc sulfate can be produced in a similar method. We can have magnesium nitrate. Magnesium nitrate can also be produced by the same method. We can have calcium chloride. It can be produced using the same method of reaction between an acid and a metal oxide. We can still have more like sodium chloride. Maybe one more. We can have zinc nitrate. So these are just some of the salts which can be produced using this method of reaction between an acid and a metal oxide. So in terms of the reactions, this is how these salts are produced. We start by zinc sulfate. From the name, it means we're reacting zinc oxide with sulfuric acid. So this is the reaction. So these are the reactions. The reactions are as follows. So the first one, we are reacting zinc oxide with sulfuric acid. Zinc oxide reacts with sulfuric acid. Remember, sulfuric acid is dilute. So we put aqueous, we shall get a salt. And that salt is called zinc sulfate plus water. So we get two products. You can balance. If you check, it's already balanced. The other salt is magnesium nitrate. From the name nitrate, it means we are having nitric acid being one of the reagents. So we are saying that magnesium oxide will react with nitric acid, and then the product will be magnesium nitrate. When you're writing the formula, you should be careful with the valencies and water. So let us check if it is balanced. Magnesium atom is 1 on the left, 1 on the right. Check oxygen atoms, 1 on the left plus these are 4. This side has 3 times 2, that is 6. You add 1, 7. So that means oxygen atoms are not balanced. Come to hydrogen. This side has 1 atom. This side has 2 atoms. Come to nitrogen. This side has 1. This side has 2. So the easiest way of balancing is if you put 2 on nitric acid, it will mean I'll have 2 atoms of a hydrogen on the left and 2 atoms of hydrogen on the left. What about hydrogen atoms? This will be 2 times 3. This is 6 plus 1, 7. 3 times 2, 6 plus 1, 7. That means we have balanced the atoms of oxygen. The next one is calcium oxide. Remember, we are looking at how the salts are formed by the reaction between an acid and a metal oxide. So how can we form calcium chloride? So from the name chloride, it means we are using hydrochloric acid. So this will be the reaction. It's going to be calcium oxide reacting with HCl, the other name, hydrochloric acid. Don't forget to put the state symbols. This one is solid, this one is aqueous. So this will give you a salt, and that salt is called calcium chloride. It's aqueous, and then plus water. After writing, don't forget to balance. We put 2 on hydrochloric acid, then the equation will be balanced. The other salt is sodium chloride. We can obtain sodium chloride by reaction between sodium oxide and hydrochloric acid. This will still give you a sodium chloride. So the reaction takes place. We get sodium chloride and water. So we check if it is balanced. You can see we have 2 atoms of sodium on the left hand side. The right hand side has 1. So we have to balance by putting 2 on sodium chloride. That will mean I will have 2 atoms of sodium on the right and 2 on the left. That calls us to also check whether I'm having equal atoms of chlorine also on the left and on the right. Chlorine atoms is 1 on the left. This side has 2, so I have to balance. I multiply this one by 2 like that. So That will mean that I will have 2 chlorine atoms on the left as well as 2 hydrogen atoms on the left. Remember, the right hand side also has 2 hydrogen atoms, so the equation is balanced. Maybe one more. Formation of zinc nitrate. We need to know that zinc nitrate is formed from nitric acid. That means we are reacting zinc oxide with nitric acid, as we can see there. Our salt will be called zinc nitrate. Zinc nitrate, I should be careful with the valencies, and water, and then you balance the way we have seen earlier. You balance, you put here 2, the equation will be balanced. So we are saying this, learn that salts can be prepared by reaction between a metal oxide and an acid. That will give you 2 products. You'll get a salt and hydrogen gas. So having said that, I want you to try these questions during your own free time. Try these questions, they'll be good for you. So our first question is state why excess copper oxide was used during the reaction, during the experiment. State why excess copper oxide was used during the experiment. Question number 2 is give a reason why the acid was warmed first. Give a reason why the acid was warmed first. And then lastly is write balanced chemical equations for the following reactions. For these reactions, write balanced chemical equation for these reactions. So the first reaction is between zinc oxide and sulfuric acid. You try that one, get the products. We are still reacting a metal oxide and an acid. The second one is try and write the reaction between magnesium oxide and hydrochloric acid. So you'd still get a salt and water. So we have just looked at how to prepare salts by reacting an acid and a metal oxide. I want us to look at another method of preparing salts. This time around, we are looking at the reaction between an acid and a metal hydroxide. So that is the one I want us to look at. So we are looking at reaction between an acid and metal hydroxide. Remember we said both metal oxide and metal hydroxide are regarded as bases. Don't forget that. So I want us to consider a very simple experiment here. Preparation of sodium chloride. Let us consider that one for this particular discussion. So let's look at the procedure briefly. The first thing you do, remember we want to prepare sodium chloride, and we're learning about reaction between an acid and a metal hydroxide. So you should be able to know the reagents that we need here. So procedure number one is measure about 25 centimeters cubed. Measure about 25 centimeters cubed of sodium hydroxide solution, and transfer into a beaker. So I believe you can do it. You just measure using a measuring cylinder, 25 cubic centimeters. Secondly, after doing that, you add 2 or 3 drops of phenolphthalein indicator. In Form 1 we learned about indicators, and one of them was phenolphthalein. So you should be able to tell the color of this solution when I add phenolphthalein indicator. So phenolphthalein indicator we are adding in a basic solution. We expect the color to be pink. So when I add 2 or 3 drops of phenolphthalein here, I'm supposed to have the solution being pink in color. We shall see the main use of the indicator in a moment. Thirdly, you add about 25 centimeters cubed of hydrochloric acid to the solution until the pink color disappears. So the disappearance of the pink color will be an indicator that the reaction is over. Remember, we are having a reaction between hydrochloric acid and sodium hydroxide. So we are using an indicator, and this indicator will be used to show the end point. So the indicator here will be used to show the end point, and the end point simply means the point at which all the acid has been completely neutralized. That's the main use of the indicator. Okay, fourth point, transfer about 25 centimeters cubed of the resulting solution into an evaporating dish. Now remember, the resulting solution is the product of the reaction between hydrochloric acid and sodium hydroxide. So when hydrochloric acid reacts with the sodium hydroxide, we shall get a salt, and that salt is called sodium chloride. So we are going to have two products. We shall have sodium chloride and water. So that sodium chloride is the one that we shall now put into an evaporating dish. Remember, we want to obtain solid sodium chloride. Therefore, we have to carry out evaporation. So you put it on an evaporating dish. Lastly, evaporate the solution. Evaporate the solution until it is about to form crystals. So how do you tell? It's about to form crystals? We say you take a clean glass rod and then you dip into that solution that you are evaporating, and then you hold it in the air. You allow the need to cool down, after which you will observe the crystals. The crystals will be seen on the glass rod. That will mean the solution is ready to form crystals. Then, after that, you allow it to cool. Allow it to cool. Allow it to cool. So, that is the brief experiment. Let's look at the discussion, the expected observations. Discussion. So remember, we are reacting an acid and a metal hydroxide. So for this particular experiment, the reaction was between sodium hydroxide and hydrochloric acid. So this will be the reaction. Sodium hydroxide reacts with hydrochloric acid, and that will give you sodium chloride plus water liquid. So this one is aqueous, this one is also aqueous, this one is also aqueous. So we are saying metal hydroxide plus an acid, you get a salt and water. Other salts prepared by the same method. Other salts prepared by the same method include. So we have quite a number. We're just going to mention a few of them. We have salts like magnesium chloride. We have salts like sodium sulfate. We have salts like potassium nitrate, etc. So let us see how are they prepared using equations. So these are the reactions that will take place in this one. So magnesium chloride is a product of reaction between magnesium hydroxide and hydrochloric acid. Remember what we are handling, metal hydroxide and an acid. So this will be the reaction. Magnesium hydroxide aqueous reacting with hydrochloric acid, and that will give you magnesium chloride and water. You check if the equation is balanced. Of course, we have one atom of magnesium on both sides. It's okay. Come to oxygen. We have 2 atoms of oxygen on the left and 1 on the right. That means oxygen atoms are not balanced. Come to hydrogen. This one has 2 plus 1, 3. This side has 2. So it's not balanced. So we have to start by balancing the hydrogen atoms. We want to make this side to have even. So we shall put here 2 so that I'll have 4 atoms of hydrogen. Then I put here 2 so that I'll have 4 atoms of hydrogen. And by so doing, we shall have balanced our equation. Next, sodium sulfate. Sodium sulfate, remember, metal hydroxide and an acid. So sodium sulfate is coming from sulfuric acid. So we are reacting sulfuric acid and sodium hydroxide. So this would be the reaction. Sulfuric acid plus sodium hydroxide. What will be the products? The products will be a sodium sulfate aqueous plus water. Don't forget to balance. We put 2 here, then we shall have balanced the equation. Maybe lastly this one, nitric acid. We are reacting nitric acid with the potassium hydroxide, which shall get potassium nitrate. So nitric acid reacting with the potassium hydroxide, that will give you potassium nitrate aqueous plus water. That will be our other product. If you check keenly, the equation is balanced. So learner, we have come to the end of our lesson. Remember, we have learned method number 3 of preparing salts, which involves the reaction between an acid and a metal hydroxide. We have said the acid reacts with the metal hydroxide to form a salt and water. So I want you to try these questions. Try these questions during your free time. So the first question is, you are supposed to define the word endpoint. Endpoint. Remember, we have mentioned somewhere the word endpoint, and this comes in when we are handling an indicator. So define the word endpoint, and then secondly, write balanced chemical equations. Write balanced chemical equations for the following reactions. The first one is ammonium hydroxide plus sulfuric acid. Get the products. The next one is magnesium hydroxide plus nitric acid. Maybe one more is zinc hydroxide reacting with hydrochloric acid. Try and write those equations. They just give you a summary on what you have learned today, that we can prepare salts by reacting a metal hydroxide and an acid. So that is the end of our lesson for today. I want to thank you for being a good student. I'll see you in our next lesson.
Hello learner, welcome to Manifested e-learning platform. My name is James Kenyani. We are yet again going to start on a new topic, reflection and congruence, as written on the board. And as usual, as we start a new topic, it's good to know some of the objectives and why we are learning the topic. So this topic enables the learner to discover properties of reflection and congruence. So by the end of the topic, the learner should be able to state properties of reflection as a transformation, use the properties of reflection in construction, and identify images and objects. Thirdly, make geometrical deductions using reflection, apply reflection in the Cartesian plane, and 5, distinguish between direct and opposite congruence and identify congruent triangles. So in our lesson today, we are going to look at initial stages of the topic. Lesson we shall look at lines of symmetry of a rectangle and a square. So our objective at the end of this lesson, you should know what symmetry is and be able to identify the lines of symmetry of a square and a rectangle. So one would ask himself, what is symmetry? Symmetry, in simple terms, somebody will say looking the same. But symmetry is a balanced and proportionate similarity which is found in two halves of an object. So symmetry it is a balanced and proportional similarity found in two halves of an object. Further, you can further say that is one half is a mirror image of the other. What I'm trying to say is that if you look at one half, it will be exactly the same as the other half. Exactly the same. So we go straight to what we wanted in the lesson. We shall start with a rectangle. Whatever I'm holding here is a rectangle. So from our definition, we find we want to look for lines that can divide the rectangle into two. So that is what you look at as a rectangle. Let's try and see. If I fold this way, I can fold that way. So the aperture of the line is seen. You see, this side is exactly the same as, the right side is exactly the same as the left part. That is one line. One line. So one line of symmetry is vertical. One of it means will be vertical. I can also fold it. I can also fold it. I can also fold it horizontally. I'll also get a line of symmetry. So you find I've got two. I can try to fold it along the diagonals. Do I get two exact halves? I think I'll not get two exact halves because they tend to overlap. It doesn't fit exactly on that. So for a rectangle, we see we get two lines of symmetry, one vertical and another one horizontal. So if we have a rectangle A, B, C, and D, as you've seen from that rectangle, we got two lines of symmetry. But that is we defined using that carton. But how can you get them by construction? It will mean if you bisect any of these sides, opposite sides, the bisector will cut the rectangle into two. So if you want to get the bisectors by construction, you can simply bisect any of the pairs. You can come and bisect these. Increase it a bit. Can come and bisect this. Need to increase it a bit. So if I prolong the intersection, of that bisection, that will be one of the axes. I'll get a line of symmetry. That is a line of symmetry. And if I want to get the other line, I'll do the same. I'll bisect any of the pairs. I'll bisect any of the pairs, either AB or CD. I'll come and bisect. So you should know how to get them by construction. Strike an arc, remove, strike an arc. So I join, I'll come and join the intersection. So that is a line of symmetry. That is a line of symmetry. So you can say a rectangle has two lines of symmetry. As shown above. So having seen for that, we shall also come and look at a square. We also have a square. It's good to look at it from an object. This is a square. This is a square. All the sides are equal. Let's see if we can divide it exactly into two parts. You can either fold it that way. I would have divided into two equal parts, or I can fold it that way. I'll divide into two equal parts. I can also fold it along the diagonals. That will be the third line. I get two equal parts. I can also fold it on the other diagonal. And fold it on the other diagonal. I'll also get a line of symmetry. So from my diagram, it seems we have one horizontally, one vertically, one along one diagonal, and one along the other diagonal. So a square will have four lines of symmetry. One vertically, another horizontally, another one on one diagonal, another on the other diagonal. So when you talk of a square, you can have a small square there. So to demonstrate the difference, you can put this and put that. That would show that one of the sides, not all are equal. Only the opposite pair is equal. That is a square. I can indicate with that to show that all sides are equal. I can say PQ R S. And from our diagram, we've got that this was a line of symmetry. This was a line of symmetry vertically. So use arrows. That was a line of symmetry. This was also a line of symmetry from what I demonstrated practically. That was a line of symmetry, and along RQ that was a line of symmetry. Similarly, if you want to construct the lines of symmetry as shown here, everybody will now know how to bisect that. Bisect any two of the opposite side, you'll get one line of symmetry. Bisect the other, you'll get one line of symmetry. Draw a line along one diagonal, you'll get one and get one. So in total there are how many? 1, 2, 3, and 4. So a square has 4 lines of symmetry. A square has 4 lines of symmetry. Lines that can divide it into exactly 2 halves. Lines that can divide it into exactly 2 halves. Lines that can divide it into exactly 2 parts. Just for the beginning, in the assignment, and before we go to the assignment, let's do a small recap. We started by defining what symmetry is, and we said symmetry is a balanced and proportionate similarity found in any 2 halves of an object. It is like a mirror. One half is like a mirror of the other, exactly the same. Then we've come to a rectangle, and we found it has 2 lines of symmetry. One line that cuts that, which means if you cut this, use the line, this part will land on that, that on land. You'll get 2 exact halves. Horizontally, you'll get another line of symmetry. So these are the lines of symmetry. Don't forget that. For a square, this is 1, 2, 3, and 4 lines of symmetry. So don't forget that. A square has 4 lines of symmetry, a rectangle 2 lines of symmetry. So for the assignment, 1, construct a rectangle of sides 7 centimeters and 5 centimeters and draw its lines of symmetry. Number 2, draw a square of side 6 centimeters and construct the lines of symmetry. So at that juncture, we identify you can only get the lines of symmetry for a rectangle once you bisect any of the opposite sides. You'll get the pair. For a square, you can bisect any of the 2 sides, or after getting it, the 2 you join the 2 diagonals. So at that juncture, I hope you'll go through the solutions for those before we proceed with the topic in the next lesson. So thank you and bye. Hello learner, welcome once again to Manifested Online Classes. My name is James Kenyani. We are going yet again to proceed with our topic on SADS, and today we are going to look, in the lesson we shall look at rationalizing the denominator. Rationalizing the denominator. So with the lesson rationalizing the denominator, the objective is to enable the learner to use the method of rationalizing to simplify SADS. So the objective is to enable the learner to use the method of rationalizing to simplify SADS. So somebody would ask and say, what is rationalizing? Rationalizing is expressing a fraction having a SAD in the denominator such that there is no SAD in the denominator. So to rationalize, so that is what rationalizing is. Rationalizing is expressing a fraction having a SAD in the denominator such that you remain with no SAD in the denominator. So it's best looked at when you have examples. You can be told simplify by rationalize. So they can tell you simply rationalize the following. Rationalize the following. One over the square root of 5. So to rationalize this, I'll look for a number equivalent to 1. Equivalent to 1. So we'll say square root of 5 over square root of 5 is equivalent to 1. So when you want to rationalize, you'll multiply by you see, when you multiply a number by 1, you don't change it. So that's why the method is used to simplify. So to rationalize, this will become 1 over square root of 5 times square root of 5 over square root of 5. That's why I've told you square root of 5 over square root of 5 is 1. When you multiply something by 5, by 1, you've not changed it. So in that case, why they use this method to simplify or to make the denominator not to have a SAD. So it will remain with 5 over, in the last lesson when we have this, you shall have square root of 5 into this root sign, you'll have 5 times 5. So it will become square root of 5 over square root of 25. Square root of 5 over the square root of 25. Simplified, it will become square root of 5 over 5. So that is the final answer of rationalizing. So I've rationalized that. I've simply multiplied the numerator by both the numerator and the denominator by the denominator. So you multiply by square root of 5 over square root of 5. B 1 over square root of 7. It will still be the same. You'll say square root of 7 over square root of 7 will be 1. So you'll multiply by square root of 7 over square root of 7. You don't seem to be changing it. That's why they say you are rationalizing. So it will be 1 over square root of 7 times square root of 7 over square root of 7. It will become square root of 7 over square root of 7 times 7, which becomes square root of 7 over square root of 49 learner, which finally comes to square root of 7 over 7. You finally rationalized that. You see what is happening, eh? But we shall look at a second example. In 2, you are told simplify by rationalizing the denominator. Simplify by rationalizing the denominator. We have 1, 3 over square root of 5 subtract 1, and 2 and 2 and 2 we have 4 over 6 minus square root of 5. Here it will be a bit different. There is something they call a conjugate surd. You look for a conjugate to make sure that you don't remain with a surd here. You'll use a conjugate surd. You look for the conjugate, and before you look at that, if you have, so you realize A minus square root of B is the conjugate surd, of A plus square root of B. So in this case, when you rationalize using that, you multiply the denominator and numerator by the conjugate surd of the denominator. So to rationalize here, you have to multiply the numerator and denominator. So to rationalize, multiply the numerator and the denominator by the conjugate surd, you'll have to multiply both the numerator and the denominator by the conjugate surd of the denominator. You'll have to multiply by that conjugate surd. So in our solutions, this is what we are going to get in 1, 3 square root of 5 minus 1. And since I've told you this is what you multiply the numerator and the denominator, you'll come and say 3 square root of 5 plus 1, the conjugate surd of the denominator. The conjugate surd of the denominator is multiplied by both the numerator and the denominator. So how does that work? You open the brackets. Then here you come, open the bracket, square root of 5 times square root of 5, you'll have square root of 5 times square root of 5 minus plus square root of 5 minus square root of 5 plus 1. Let's look at what will happen. This square root of 5 cancels with that square root of 5. Square root of 5 times 5 is square root of 25. So this will work to 3 square root of 5 plus 3 over square root of 25 plus 1. So learn how does that come, what does that come to? Square root of 25 is 5. So it will be square root of 3 square root of 5 plus 3 over 5 plus 1 over 5 plus 1. It works to 3 square root of 5 plus 1 over 6. That is the simplified form by rationalizing the denominator by multiplying by the conjugate surd of the denominator. So first of all, you get the conjugate surd. Then you multiply it by both the numerator and denominator. That is rationalizing using what? Using the conjugate surd, or we simply say rationalizing the denominator. We shall look at the second example where we have 4. We shall come to 2. Number 2. You are given 4 over 6 minus square root of 5. The first thing is to get the conjugate surd of this. The conjugate surd of the denominator is of 6 subtract square root of 5 is 6 plus square root of 5. So you'll go straight to multiplying by each. So this will come to 4 into 6 square root of 5 over, when you do this you are rationalizing, over 6 minus square root of 5 into 6 plus square root of 5. So you simplify. 4 times 6 is 24. 4 times 6 is 24. 4 times square root of 5 is 4 square root of 5. We come down. 6 times 6 is 36. 6 times 6 is 36. Then we have 6 square root of 5 minus 6 square root of 5 plus 6 square root of 5. You start with plus, then minus 6 square root of 5. Then you finish up with the square root of 5. Square root of 5 times square root of 5. Let's simplify. The denominator remains the same. 24 plus 4 square root of 5 over this and this cancel, plus 36 minus square root of 25. Square root of 5 times square root of 5 is square root of 25. So you'll have 24 plus lana 4 square root of 5 over 36 minus 5. 36 minus 5. This will work to 24 plus 4 square root of 5 lana over 31. That gives us our answer. That gives us our answer. So in such a case, you look for the conjugate surd of the denominator and multiply it both by the numerator and the denominator. So having done that, it will be time for an assignment. So before I go to the assignment, know what a conjugate surd looks like. The sign changes there. If it was positive, it becomes negative. A minus B is the conjugate surd of A plus square root of B. So, Lana, that was the assignment. Rationalize the denominator. You saw how we went about. So, A, 1 over square root of 2. B, square root of 2 plus 1 over square root of 7. C, 1 over square root of 3 plus 1. D, square root of 2 over square root of 11 plus 4 square root of 10. So, here you need a conjugate surd. In these two, you need a conjugate surd. These ones you multiply, just multiply this by square root of 3 over square root of 3. Multiply here, square root of 7, square root of 7. But in these two, you need the conjugate surd. So thank you very much for the audience. Work through the assignment and get the proper inclination to the operations in surd. So thank you very much, and let's meet in the next lesson. Bye-bye.
Welcome to our physics lesson today. I'm your teacher Purity Anzelimo, and in our lesson today we continue with the topic X-rays. So the topic is X-rays. And in our lesson today, we'll actually be concluding this topic, the X-rays. So before I mention what we are going to cover during this lesson, I would like us to do a recap on what we covered during our previous lesson, where we were looking at the intensity or the quantity of X-rays and also the strength of the X-rays. We said that with the strength, of the X-rays is determined by the accelerating potential difference between the cathode and the anode. So you need to make note of that because it will depend on the spin of the electrons which have been produced. So the strength of X-rays is determined by the accelerating voltage between the cathode and the anode. Make note of that because we think that the more the accelerating voltage between the cathode and the anode, the higher the spin of the electrons which are emitted, and therefore the higher the strength or the more the strength of the X-rays that will be produced. Then number 2, we talked about the intensity or the quantity of X-rays. And this one is controlled, or the intensity is controlled by the heating current. So we were able to see that, and we were able to explain that when the heating current is more, then there will be heating, more heating at the cathode, and therefore more electrons will be emitted. And when more electrons are emitted, it means that more X-rays will be produced. So the higher the heating current, the more the quantity of the X-rays produced. So during our lesson today, we want to look at now the uses of X-rays. This may not be very new to you because in the topic electromagnetic spectrum, where we looked at X-rays as part of the electromagnetic waves, or as part of the electromagnetic spectrum. So we are going to list those down those uses of the X-rays. We are going to divide them. For example, what are the uses of X-rays in medicine? What are the uses of the X-rays in agriculture? What are the uses of X-rays in science? What are the uses of X-rays in security? So we look at those uses because in an exam you can be told, for example, give one use of X-rays in medicine. So they can be specific to that area. So we want to look at the uses of X-rays, and we'll start with one of the categories is in medicine. In medicine, and I'm sure maybe you have ever visited a hospital, or maybe you have ever taken a friend who has undergone an X-ray. So in hospitals or in medicine, we want to see how X-rays can be of use. Now in hospitals, or what we are calling in medicine, it can be used in what we call the radiography. And we want to explain first about radiography because we can use it in radiography and also in radiotherapy. So in radiography, this is where, because X-rays, we say they have high penetrating power, even because of their position in their electromagnetic spectrum. They have high frequency and therefore they have high penetrating power. So due to their high penetrating power, they can be able to inspect the fractured bones or dislocated joints. That is in what we call the, in taking the radiographs, that is in X-rays. In taking radiographs, that photography that is obtained after one undergoes an X-ray is what we call a radiograph, and thus can be used to study the internal structures, that is the fractured bones and also the dislocated joints. So that is in radiography. So we can say that in radiography, due to the penetrating property of X-rays, we can say that fractured bones and dislocated joints can be seen. Fractured bones and also dislocated. We say that they can be seen from X-ray photograph. They can be seen from X-ray photograph, which we are calling called the radiograph. So in a photograph, an X-ray photograph called the radiograph. So when you undergo, for example, maybe if an accident occurs and maybe there is a swelling, maybe in one of your bones, let's say the leg bone, let's say at the ankle. So before the doctor treats you, he or she may tell you to undergo an X-ray. And that X-ray, now you produce, when you go for the X-ray, you will take the radiograph to the doctor, and the doctor will be able now to examine and see what the issue with your ankle. So due to the penetrating property of the X-rays, fractured bones and the dislocated joints can be seen from X-ray photograph, which we are calling the radiograph. So that is one use in medicine. Use number 2, still in medicine, is what we are calling the radiotherapy. The radiotherapy, there is a H here. Radiotherapy. Now in radiotherapy, here this is where now we talk of the treatment of diseases like the skin diseases, cancer, and X-rays are used to destroy the infected tissues. So X-rays can also be used in the treatment of cancers, that is the cancerous cells, and also the other skin diseases by exposing the X-rays to the infected areas. So that is in radiotherapy. So we can see the following in radiotherapy, that we can see that hand X-rays, especially now the hand X-rays, since we see that they have a higher penetrating power, they are the ones that are used in the treatment of cancer. So hand X-rays, they are used in treatment of cancer, tumors, and other skin diseases, So the hand X-rays are used in treatment of cancer. We also have the tumors and other skin diseases. So what they do, they destroy the X-rays, destroy the tissues, or they destroy the tissues at the infected areas. They destroy cells at the infected areas. So when you hear someone has undergone a radiotherapy, of course there are some dangers on long exposure to X-rays, but in addition to that, we still have the advantages of those rays, because they can be used in the treatment of these diseases, cancer, the tumors, and other skin diseases. So because of their high penetrating power, again, that's why they can be able to destroy, and because of their energy, they have a lot of energy, and therefore they can be used to destroy the cells in the affected or in the infected areas. So that is in radiotherapy. Is there H? No, it shouldn't be just Y. So in radiotherapy, that's how the X-rays are used. Then we can move on to another area where X-rays are used. Number 2, we can talk of in industry. Now in industry, X-rays are also very key. One, they can be used to detect flaws or any crack in metals. So before those metals maybe are packaged for use, the X-rays, because of their high penetrating power, they can be used to detect the cracks or the flaws in metals. Again, in industry, the X-rays can also be used in sterilizing the medical equipment before packaging. So we can say, number 1, they can be used to detect flaws on what we are calling the cracks in metal casing. Then again, they can be used to sterilize medical equipment before packaging. So those are the uses of X-rays in industry. They are used to sterilize the medical equipment before packaging. They can also be used to detect cracks in metal casing. Now we move on to another area where X-rays are used. That is number 3. We can talk of in science. in science what we refer to as crystallography. In crystallography. Now, from this one we have crystal. So in science, X-rays can be used in the study of the structure of a crystal. In chemistry, you learn about crystals. So as a use of X-rays, they can be used to study the structure of a crystal. That is in science. That is how the layers are. That is in the atoms in a crystal. So it can be used to study those internal structures of a crystal. So that is in science, to study the structure of a crystal, or what we call the crystal substances. Then again, we can also use the X-rays. Number 4 can be used also in security. And here in security, majorly in the airports, where inspection has to be taken for any luggage that is to be transported. So it is used to inspect luggage in airports, so that in case of any hidden material that may be dangerous, so that it can be detected by the X-rays. So when one is taking a flight, the luggage that you carry has to be inspected. And what takes place is that rays, that is the X-rays, are passed on your luggage for any hidden material. For example, any weapon that may be hidden in the luggage. So we can say that in security, it is used to in airports. We'll give an example in airports. To inspect, sorry, not to detect, but to inspect. So that is in security. It is able to inspect the luggage because of, again, of its high energy. It's able to penetrate the luggage and inspect in case there is any hidden weapon. So that is in security. We've also mentioned the industry area. We've also talked about science and also in medicine. And in medicine, we can also add another use in medicine. In medicine, X-rays can also be used to detect. For example, if there is a foreign object that has been swallowed. For example, if you swallow a coin, it can be detected by the help of the X-rays. So we can also add that as a use of X-rays in medicine. In medicine, we can add and say that in this the continuation, we can say that it can be used, X-rays are used to swallow fallen objects, fallen objects, that is in the body, a swallowed coin, or even a pin. So used to detect foreign objects in bodies, a swallowed coin. So those are the uses of X-rays. So we have seen that we can divide them into 4 in medicine. So you don't need to write a lot. For example, in medicine, you just talk of in radiography, where it is used to study the fractured bones and dislocated joints. Then in radiotherapy, we are saying it can be used in the treatment of cancer, treatment of tumors, and other skin diseases. And then we are also saying in medicine can be used to detect foreign objects in bodies, a swallowed coin or a pin. Now in industry, you just talk of used to detect cracks in metals, used to sterilize medical equipment before packaging. In science, used in crystallography, where we study the structure of crystal substances. Then in security, to inspect luggage for any hidden weapon. So those are the uses of X-rays. And now we want to move ahead and look at the dangers of X-rays. Despite the fact that X-rays are very useful, actually, like in medicine, this is what we rely on, the X-rays. Despite the fact that they are very key in our day-to-day lives, they also have some dangers when they are overused. So long exposure to X-rays can be detrimental to health. For example, we can say that one of the dangers of long exposure to X-rays is that it can affect the skin. It can even lead to cancerous cells due to its long exposure. So care must be taken even when one is undergoing the X-rays. So we can say that the penetrating property of the X-rays can cause genetic changes and even diseases like cancer. That is on long exposure. So number one, due to and that's why you are always asked when maybe, for example, you go to a hospital and you want to undertake an X-ray, you are asked how many X-rays have you gone through, maybe in that year, because a lot of exposure to the X-rays can be very detrimental. And again, that's why in the rooms where X-ray machines are kept, there are not many people in those rooms. Actually, when you take a person to undergo an X-ray, you'll be told to wait for that person outside that room because of those X-rays. Because in case there are stray X-rays, if they land on your body or on your skin, they can lead to health issues. So due to the penetrating power of X-rays, it can cause genetic changes and other diseases like cancer on long exposure or due to long exposure. Then we can also say another danger, we think that they have high ionizing power. X-rays have high ionizing power, or they are able to ionize gases. That is what we said in one of the properties of X-rays. We said that X-rays ionize gases, making them conductors. And therefore, due to the ionizing property, X-rays can damage the body cells. So due to the ionizing property, X-rays can destroy body cells. That is again on long exposure to the X-rays. And due to their ionizing property, where we say that they are able to ionize gases, making them conductors, then they will lead to destruction of the body cells. And therefore, care must be taken, especially when in the rooms where X-ray machines are kept. So we also look at the precautions when using the X-ray machines. Precautions, what you need to take care of when you are operating an X-ray machine. Precautions. So we have two major precautions that need to be taken when using the X-ray machines. Now these X-ray machines are the ones which are producing the X-rays. So number one precaution is that the room where the machine is kept should be a room that is built of concrete or a hand material which is able to absorb any stray X-ray. So in case, because we have seen that for even the hand X-rays, they are absorbed by the bones, so they may not be able to penetrate the concrete walls. And therefore, an X-ray machine should be kept in a room which is made of hand materials like concrete, so that the X-rays cannot penetrate. And if you look at most of the hospitals, if not all, where the X-ray machines are kept, you'll find that that room is made of it's made of concrete, or it's made of stones, because they are hard and therefore the X-rays cannot penetrate. So that is one of the precautions that need to be taken. Then we also say that those machines, when we are looking at the X-ray tube, we also say that the X-ray tube should be covered or should be coated with a metal of high density that is lead, to ensure that any X-ray that is undesirable, produced at an undesirable angle, is absorbed by that material. And a good example, we said we use lead metal, and the reason as to why we use lead is because it is a metal of high density. So we can say, number one, X-ray machines the X-ray machines have lead shield, and this is to protect the operator from stray X-rays. So that's one of the precautions, that X-ray machines have a lead shield to protect the operator from the stray X-rays. And you can be asked why lead is preferred. We have said because it is a metal of high density. Then number two, we can say that the rooms of operation have concrete walls. They have concrete walls to absorb any leaking radiations. And these radiations are the X-rays. So we are saying that the rooms of operation have concrete walls to absorb any leaking radiation or any leaking X-rays. So these are the precautions that need to be considered when using the X-ray machines. X-ray machines have lead shield to protect the operator from the stray X-rays. So the lead is able to absorb the X-rays. Then the rooms of operation have concrete walls to absorb any leaking radiations. So those are the precautions that need to be taken when operating those machines. So those are the uses of X-rays, the dangers of X-rays, and also the precautions on using the X-ray machines. Very examinable. You can just be asked a question from any part here. You can be told to give one danger on exposure to X-rays. You can be told, you can be asked, for example, to give a precaution on using the X-ray machines. You can be asked why the lead metal is preferred for shielding purposes in X-ray machines, and you should be in a position to explain all that. So I'd like to give you an exercise on what we've looked at on the uses and the dangers of X-rays. So I want to give you an exercise. 2 questions on this. Number 1, state 1. So state 1, agricultural use of X-rays. Number 2, give 2 dangers of long exposure to X-rays. And that brings us to the end of this topic, that is the X-rays. So you can revisit the other lessons for you to understand better. So during our next lesson, we'll now do a summary of what we have been covering in X-rays, and we'll also do a question from the past papers, that is KCSE past papers, and you'll be able to get it better. So let's meet during our next lesson so that we can summarize the topic. Thank you.
Hello, Lana. Welcome to Manifested Online Classes. My name is James Kenyani. We are going to come to some of the winding lessons, one of the last lessons, last lesson of the topic SADs. Having gone through rationalizing, finding what a SAD is, it is a time again to see at some further solutions in this final lesson on SADs. So it is further solutions to questions. The main objective of this lesson is to equip the learner with the necessary skills of solving questions on the topic SADs. So it is to equip the learner with the necessary skills of solving questions on SADs. And as usual, we always look at the various questions to get what is required. So this rationalize. So rationalize the denominator. That one we know because in the last lesson we looked at the conjugate SAD, the conjugate SAD. But before we go to that, the learner should have already gone through trigonometry and knows how to easily get the trig ratios of cos 45, tangent 60, cosine 30, and sine 30. So it is a remembrance thing when you look at an equilateral triangle. Learner, this is an equilateral triangle. In an equilateral triangle, I don't need to tell you that this is 60 degrees. It should be at your tips, 60 degrees. Now, if I drop a perpendicular there, I know I'll have 30. And this will be 30. If I take that trig to have 2 units here, I'll have 1 unit, 1 unit, 2 units, 2 units. So it's very easy to relate those trig ratios once we've got the rationalized the denominator. Like if I want to get, there is 30, 45, and 60. For 45, you assume you have 1 unit here and 1 unit there. So this is the hypotenuse. This hypotenuse will be the square root of 2. So this is 45 degrees. So from here you can easily get the trigs before you come and work the ratios before coming to rationalize the denominator. You can start here. The tangent of 45. The tangent of 45, learner, is opposite over adjacent. Opposite over adjacent. It is 1 over 1. It is 1. You can want to get the sine of 45. Sine 45 is opposite over hypotenuse, learner, which is 1 over square root of 2. You can get the cosine of 45. Adjacent over hypotenuse, 1 over square root of 2. I would have already got that, and some of them seem to be in SAD form. I'll come here, 30. Sine of 30 from here, opposite over hypotenuse, 1 over 2. The cosine of 30, there is one thing I've not got here. If this length, if it is kt, this will be the square root of 3. because 2 squared, square root of 2 squared minus 1 squared will give square root of 3. Kt is equal to 2 squared minus 1 squared, which gives square root of 3. So the cosine of 30 will be 1 over square root of 3. Tangent of 30, opposite of adjacent. Let's look at the cosine of 30. Adjacent over hypotenuse. So it's, square root of 3 over 2. Tangent of 30, opposite of adjacent, 1 over square root of 3. We now come to sine of 60. The sine of 60. We start here, opposite over hypotenuse. Square root of 3 over 2. Cosine of 60, adjacent over hypotenuse, 1 over 2. And the tangent of 60, opposite of adjacent, square root of 3 over 1, which is square root of 3. So that one is able to help you as you rationalize. So we go to the solutions here. The solution, this will come to, you look for the conjugate side. Conjugate side of 1 minus cos 45 is what? 1 plus cos 45. So it is the conjugate side that will multiply by the numerator and the denominator. So this comes to 2 times into